Okay, and welcome back. Thanks to everybody who decided to stick around. Having said that, I am actually just going to take a short break now because that question was just a little bit. Sorry, that paper was a little bit frustrating. It kind of took the wind out of my sails a little bit. So just for like 5 minutes, I just need to stand up, walk around a little bit, because we're 9 hours in, but we have got 13 hours to go. Coming up next is the conclusion of our journey through mathematics, and that is the degree level paper. So this is the kind of thing that you would see in first year. Oh, we're getting microphone feedback.
No, sorry, that was me. That's
Oh,
my
sorry. Okay, no worries. Yeah. So this is the sort of thing that you would see in your a first year degree. I've taken this from a semester one. So it's kind of end of first semester, first year. So pretty. Well, I say basic stuff. I really shouldn't. I really should stop saying things like that. So let me get my blackboard, and I'm just gonna stand up, walk around for 5-10 minutes. So I'll be back at something around quarter past.
I couldn't have joined at a better time. Hiya.
So good.
Absolutely nailed it.
Yeah, that's great. Okay, so I think Ollie said that he was going to depart because I mean he has been on for 9 hours, so he's been an absolute hero. Thank you so much for all of your help and support with this, Ollie. That's absolutely fantastic. And joining us, we have my good friend. It's going to sound silly, but Creamer is what I call him. I mean, he calls me Magoo, so he can't get more silly than that. Um, yeah, so feel free to chat. Like I said, I'm just going to be gone for like 5 minutes or so.
Okay, perfect.
Yeah, so you might want to just introduce yourself a little bit. Tell everyone just a little bit about you,
Sure.
and then maybe we'll take some questions from the chat.
Yeah. Okay. Perfect. Yeah. So I'm Adam. Adam Creamer. So that's why Magoo calls me Creamer because that's way more interesting than Adam. And I basically went to college with Magoo. We've been friends ever since. I'm a researcher at Imperial College in London, working working mainly on sort of nanoparticles and like chemistry for towards kind of diagnostic tools, mainly towards cancer. But it's all very very varied. Um, yeah, so maths was my I really enjoyed maths at school, but now maths, but rarely. I just basically use two equations every day, and that's it. And it's very basic. So my maths knowledge is definitely weakened over time.
No, don't worry. I think next up we're gonna have to take a look at one of the um, first year undergraduate papers. So this is yeah, first year
Yeah.
university level. So there may be some new stuff there for you. I'll stick around for a little bit longer as well.
Okay.
Um, yeah, so that's that last further maths paper was really quite tough. Um, I think the one of the papers that he will be doing later on is going to be the further additional maths. So we've just seen further maths, but there is also a qualification. This is before university level, that is additional maths, which
Right.
was just always described to me as it wasn't meant to be harder; it's just meant to be very different. So I think that's
Okay.
going to be really interesting coming up. I've never seen one of those papers, so I'm
I
super
was going to say,
excited.
that's a relatively new thing that's been introduced.
No, it's just something that not very many schools will
Right.
offer.
Right. Got you. Okay.
Because there's typically only between say 300 to 400 people taking it. It's there's really not very many. Elliot, I think the paper that's going to be doing. So Alex will confirm, but I think it will be a Manchester paper, Manchester University. I'm not sure whether it's going to be sort of a sets, numbers, and functions kind of paper, or if it's going to be a linear algebra paper. I think we've got both of those on the agenda for the 24 hours.
It sounds like Alex was suggesting this might be easier than the further maths that he did.
Yeah, very much so. So
Seems a bit sort of, I don't know, counterintuitive.
yeah, so not everybody who does mathematics, who goes and does and studies mathematics in the UK will have done the further maths paper. So
Yeah.
a lot of the first semester courses are really there to get everyone up to speed. So
Yeah,
to get
yeah, that's fair.
everybody back onto the same level. So you do tend to find that the papers in the first semester of a first year mathematics course tends to be easier than some of the later papers in the A levels.
Yeah, okay, that makes sense. Yeah, I remember my first year in chemistry was a huge amount of math. It was very sort of, it was definitely applied though. There was no more. It was like, again, it was giving us the foundational stuff that we needed to do, quantum mechanics, or we did a bit of set theory for like, what was it applied to? It was like, for more like some spectroscopy has set theory behind it and things like that. So it's basically just getting your basics there, which is quite good. Because that's where I was way more interested in maths, was the applied. That's what me and Magoo deviate massively.
Yeah.
But because did you do maths at Manchester as well?
Yeah, so I did most of the same courses as Alex. Alex was very much so focused on algebra, like very very group theoretic. Group theoretic courses. I did quite a bit of that as well, but then I also did some finance and some geometry in there as well.
Okay.
So we were mostly doing the same thing. Oh, that's a good question, Dave.
That is a good question. So it's just one of those silly things. So Alex's last name is McGaw, and then so it just become, someone said Magoo one day, I think, basically, and it kind of stuck.
Yeah, that's it. So literally, it's so dumb. It's amazing that everyone still calls. Well, not everybody. It's just you, because I've got like two main groups of friends. I've got like friends from back home. They all call me Magoo because they know me from school, and it's only at school that you could come up with something that stupid. And then none of my uni like math friends really call me that.
Yeah, far too serious for that.
Oh yeah.
Sort of nonsense.
Yeah, I mean it's because it's incorrect. It's not my name, so therefore, right. Well, welcome, Creamer. Thanks very much for coming on.
Pleasure.
It's really good to have you here. You told everyone that you're a cancer curing scientist yet?
Yeah, that's it. Yeah.
Yeah.
I'm going on trumpet for a little bit.
Yeah, always. No, it is important work. So I think it's a trumpet that deserves to be blown.
Oh, well, thank you so much.
Are we feeling all right? Because yeah. So let's get on with it. So this is the degree level paper. So this is from the first year, semester 1. Foundations of Pure Maths course. Now, when Dan and I did this was called Sets, Numbers, and Functions. We've got section A here where we answer all 5 questions, and then section B where usually you can choose like which questions to answer. So I'm probably going to flick through and pick the ones that are anything related to algebra, set theory, that sort of thing. Usually try to avoid the number theory, to be honest, because it's been a long time since I've looked at a lot of number theory. So let's see how this goes. Obviously, we start with the some logic here. So write down the negation of that statement. I'm really tempted to just write like not and then put brackets around it, but I think it wants a little bit more than that. So if for all x there exists a y for which x is greater than 3y, then the negation of that is that there exists an x real, such that for all y reals x is not greater than y. In other words, it's less than or equal to 3y. Now, state whether the statement or its negation is true. I think this top one is fine, isn't it? Because for all x, there exists a y. That is true. If you take any x, then if you let y equal x over 3 subtract 1, for example, then I think that works because x is greater than 3y if and only if x is greater than 3 of x over 3 minus 1, which is x subtract 3, and that is true. So the original statement is true. Okay, and then the second one, write down the contrapositive of this statement. So this is saying for all n in z. So this is saying if 5 does not divide n squared, then 5 does not divide n. The contrapositive of that is if 5 divides n, then 5 divides n squared. And it wants us to prove. And I think the contrapositive is easier to prove here because it's easy. It's easier to prove that when you've got a positive claim, 5 divides n rather than 5 does not divide n. So 5 divides n implies n is equal to 5k for k integer. Therefore, n squared is equal to 25k squared, which is 5 lots of 5k squared, which is a multiple of 5. Or I'll say therefore 5 divides n squared. I think that's how it wants us to say that. Okay, so nice and easy just to get us started. Okay, now question A2. I'll try. It's awkward here because
before you get on, don't forget to up the counter. Otherwise, we'll be here for days.
Ad infinitum. Yeah. So
we're not increasing.
Yeah, and I'm enjoying it. I'll be honest, but so degree level. I'll just call it pure foundations. It's a bit clunky actually. Let's do it like that. That should be fine. Okay, so you get question paper and an answer booklet, which is my preferred way of answering an exam actually, but it's a bit awkward in here. So let's do A2. A and B are subsets of a universal set. Prove that A union B complement of is equal to the complement of A intersect the complement of B. So this is like a kind of De Morgan's law, but when applied to sets. So we'll do it. We'll show that the left is a subset of the right. So let X be in this set here, which implies X is not in A union B, and in that case, X is not in A, and X is not in B. And in which case, X is in the complement of A, and X is in the complement of B. I'm using dash as my complement symbol here actually. I just noticed that. I think the dash is actually a little bit more standard. And this implies that X is therefore in the intersection of the complements. Because that means A and B. And in fact, I think this runs in reverse. If X is in the intersection, then certainly it's in both. And if it's in that and in that, it must indeed, this is just a definition. If it's not in either, it's certainly not in the union. And if it's Yeah. So I'm happy actually to just say that the superset kind of that backwards implication is kind of done there. So it kind of shows that the one is a subset of the other is a subset of the other, so they are identical. They're the same set. Okay, let A be that set, and let the function f. All right, so from ordered pairs of 1, 2, and 3 into the integers, write down the image of f. Okay, so what images do we get here? Let's do a little table for this actually. So I'm going to do this subtract this. So 1 subtract 1 subtract 2 subtract 3. 2 subtract 1 subtract 2 subtract 3. 3 subtract 1 subtract 2 subtract 3. So the image of f, that's all the numbers that you can reach in the integers, is just -2, -1, 0, 1, 2. Is f injective? No, as e.g. f of well, let's say 1, 1 is equal to 0, which is equal to f of 2, 2. Yet 1, 1 is not equal to 2, 2. Because the formal definition of injective is f of x equals f of y implies that x equals y. So basically, if two things map to the same element, they must have been the same element to begin with. Or the contrapositive is sometimes more intuitive. If they start different, they finish different. So in other words, it's a one-to-one function. So both of those are fine. I actually think the top one is the standard. The bottom one I think is more intuitive. And 3, state the pigeonhole principle, which to the non-mathematicians watching, if there are any, it is a real thing. It sounds a bit weird, doesn't it? So the pigeonhole principle, that just says if you've got n objects into k bins, so you've got your n objects and you put them into k bins where n is greater than k, so more objects than bins, then there is at least one bin containing at least 2 objects. Because no matter how you try to assign them, you'll always need to, because you've got more objects than bins. I suppose this is about functions. So I suppose, what is it saying? F from A to B, where mod A, sorry, the cardinality of A is greater than the cardinality of B. So if we've got that, then F is not injective. Which is the same, it's the same thing. If you've got a set here, and you're going into a smaller set, you cannot possibly have an injective function. You have to repeat an element at some point. So you learned that in high school. That's interesting. I would have loved to have gone to your school. I certainly didn't see it until I did my degree. High school, I guess for you might be what we call college. So I guess you might there might be some scope where you might have seen that. But yeah, different schools, different times. So A3. Use the method of successive squaring to find the remainder of 2 to the power 65 when divided by 100. Right. What is that then, do you think? I think this is talking about, so if we do 2 to the power of 64, so 2 to the 65 is 2 to the 64 times 2. So 2 to the power 4 is 16, obviously, so this is congruent to 16 modulo 100. And then if we square both sides of this, 2 to the power of 16 is congruent to like 16 squared. So that's 56 mod 100. And then 2 to the power 32. So we square again. 56 squared is 36 mod 100. And then 2 to the 64 is congruent to 36 squared. 96 modulo 100. And therefore 2 to the power 65 is, if we do 96 times 2, that's congruent to 92 modulo 100. So the remainder is 92 when we divide 2 to the power 65 by 100. Oh,
We got a
yeah,
comment.
yeah, okay, yes. So this is bad, actually. This kind of throws the whole thing out of whack. So 2 to the power 8. So actually, I think I just need to go one more step here. So yeah, I just spotted that in the comments there. So actually, yeah, if we just, that's 8, that's 16, that's 32. So it's not, the damage isn't too bad. I can just do 2 to the power 64. So if I do 96 squared, that is 16 modulo 100. So therefore 2 to the power 65 is congruent to 32 mod 100. Yeah, well spotted. Thank you for that. So hence or otherwise, find the last 2 decimal digits of that. Well, oh god, 798 is equal to 200, 2 times, oh god, well, it's 1 less than 400, so 399. Oh, I know what we're gonna do here. Oh, this is good actually, because yeah, I panicked for a little bit there, but this is fine. So, 798 to the power of 65 is equal to 2 to the 65 times 399 to the power of 65. Now, this is congruent to 32 times negative 1. Sorry, negative 1 to the 65 modulo 100, because 399 is congruent to 99, which is congruent to negative 1 mod 100. I think this is how it works. So, and then negative 1 to an odd power is negative 1. So this is negative 32 modulo 100. And therefore, 68 mod 100. Yeah, I thought that was going to be tricky. It's one of those where if you don't spot it straight away, you can be wrestling with it for a while. Now, you are given that a natural number is such that 2 to the n leaves a remainder 2 when divided by 100. Prove by contradiction that n is 1. Let's flip over. So, 2 to the n... Okay, so assume n is not 1. And since it's natural, we are talking about greater than 1. I suppose if we think the natural numbers start at 0, that is 1, which is not congruent to modulo 100 anyway. So if you assume that n is greater than 1, let me just get a feel for this. So 2 to the 2 squared is 4, and then if we double these, 64. Oh my god. 64 times 2 is yeah, 28 obviously. What am I doing? Ah. Oh no. So imagine having 2 to the power n being congruent to 2 mod 100. What would have to happen? Because we're doubling here. My gut is telling me that this can't happen because how would we get a 2 there? We would need an odd number there, which can't happen. The only time you get an odd is by getting 2 to the power 0, which is 1. That's why it happens at 2 to the power 1, but never again. Because 2 to the n is even for all n naturals n greater than 1. So I think this is right. The only way to get a 2 there is if you have 1 or you have something and 51. So that when you double it, you get something 02, which modulo 100, you strip away all of this stuff and you're left with 2. So I think if you put those pieces together, this is fine. I wonder if there's an easier way of doing that. Anyone in the chat have a good way of doing that one?
A comment from Luke Skywalker that might help.
A comment from Luke Skywalker.
Yeah.
His area of X. Oh yeah, I see. I think I see where this is. Yeah, so I think this is what I maybe tried to do up here, but just failed to actually make anything of it. So basically, this kind of thing maybe is 2 to the n minus 1 minus 1 is equal to 100k, which means 2 to the power n minus 1 is equal to 50k, which means this is even. Oh yeah, but we know that anyway. Yeah, how do you get that? Oh sorry, this is odd when this is even, and that is even. Yeah, okay, that's another way of doing it, because this is odd whenever that is even, but we have to get an even number on this time because it's 50 times something. So yeah, I think that will do it. Yeah, so jazzedly, this is what I was doing here. I was doubling it, but then I quickly realized this isn't going to loop very quickly. I've actually got a feeling this loop will go on for a long time. Maybe it won't, but I don't know. Once I got 28 there, I thought, okay, 7 is now involved, and that I actually think that will loop for quite a while. But I mean, it will loop across some even integers. Okay, so A4. Let phi be Euler's phi function. Oh god, that came up in one of my videos recently. Oh wait, no it didn't. It came up in a video about 9 months ago. The totient function I usually call it, actually. So basically, phi of n counts the number of integers from 1 to n which are co-prime to n. And write down a formula for that, where p and q are prime, hopefully, because you do 1 subtract the reciprocal of each distinct prime and times them all together and multiply by the number itself. I think is what you do. Is that right? For instance, I want to actually just check I'm right here. So 12 is 2 squared times 3. I think if we do 12 times 1 minus 1 over 2 times 1 minus 1 over 3, this will give us the number of coprime integers less than 12. So that is a half times 2/3 is 2/6 times 12 is 4. So how many coprimes do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think this is right. I think this is right. Based on my one test. I think I've got the formula right here. So, because it's p times q, they are the only primes in that number. So whatever p times q is, its prime factorization is pq. So phi of p to the k q to the k is the number itself times 1 minus 1 over p times 1 minus 1 over q. And then if we divide it, we actually want a formula for this. That's why I've written it with the k outside again, because now we divide by that, and it just becomes that. So 1 minus 1 over p, 1 minus 1 over q. Okay, hence or otherwise show that 10 to the minus k multiplied by 10 to the power of k is 0.4. Okay, well, 10 is equal to 2 times 5, so it is of the form p times q. So 10 to the power k is that. And we've got it in the right form. So phi of 2 times 5 to the k over 2 times 5 to the k, because it's a negative index, we'll push it down there. Now it's in the form of the previous step, so this is just 1 minus 1 over 2 times 1 minus 1 over 5. So 4/10, which is, 0.4. That's it. Odd that they've chosen to use a decimal there. Is it possible for phi of pq to the power of k to be prime? Well, no, because we did one here, and it's even. Well, it's 4, so it's not prime. But this isn't in the form. Well, what was phi of 10? What is phi of 10? How many coprimes do we have? So it's 10. 1 minus 1 over 2. I'm trying to prove it false at the moment, because that's usually easier. So this is 10 times what we did last time. Oh yeah, so there we go. There are phi of 10. So if you choose p equals 2, q equals 5, k equals 1, false by counterexample. I wonder if I mean 2 times 3. Because 6. What's phi of 6? Because there's not many coprimes. Yeah, 1 and 5. Oh, that is prime. By that I mean these are that's the size of the that's 2, so that is prime. So we did have to go to 2 times 5. I think I'm happy with that. Yeah, you always want to try and prove things false before you prove things true. That's just good practice in these sorts of games. Oh, here we go. Now we're talking. We're doing some mathematics here. This is, here we go. This is group theory. Well, it's the precursor to group theory. This is like, let's teach you how to shuffle around permutations, and then we'll look at them in the group context. Because group theory is pretty much all about permutations, really, when you break it down. Well, I should say finite group theory, as if there were other kind. Yeah, because Cauchy's theorem says that basically any group is a subgroup of some permutation group, or is isomorphic to some group of some symmetric group. So therefore, every group can be basically thought of as a permutation group. So that's why it's really important that I almost said kids then. Kids learn to juggle permutations. By kids, I mean first year undergraduate students. So, anyway, what the hell am I talking about? Let's do the question. So, by writing tau as a product of disjoint cycles, show that it is a cycle of length 3. Okay, well, let's get our hands on sigma. Well, let's get our hands on... Well, no, let's get our hands on sigma. Yeah, so what is... And I wonder if they're going to go backwards or forwards. I think they're going to go backwards through this, which is like the standard permutation way, but I think the old school group theory way is to do it from left to right, actually. But anyway, we've got, let's start with 2 goes to 1, goes to 2. 1 goes to 2, goes to 3, goes to 4. 4 goes to 5. And then I reckon everything else is fixed. Yep. Well, let's check 3. It should be, because I'll tell you why in a second. 3 goes to 2, 2 goes to 3, and then 6, 7, 8 don't appear. So sigma equals 1, 4, 5. This is length 3. And then I'm going to cheat here. And tau is conjugate to sigma. Therefore, tau has the same cycle type using the group theory results. So, conjugate means, so like G is conjugate to H if and only if there exists an element in your group such that X inverse G X is equal to H. And it is the case here. They've conjugated sigma into tau, and it's another result that they have the same cycle type if and only if they are conjugate in the symmetric group. So I'm happy with that. I'm cheating a little bit, but who cares? How many cycles?
Is that another donation of a £5 from Anonymous?
Thank you very much to the to that anonymous donor, whoever you may be. Yeah. So yeah. All helps. We've reached the target, but thank you for donating anyway, because it's not about earning £3. It's about trying to earn as much as possible for such a fantastic charity. So thank you very, very much. Now, how many cycles of length 3 are there in S8? Oh, my brain wants to say that, but let me just check it. So imagine you're building a cycle here. 1, 2, 3, 4, 5, 6, 7, 8. Now, you want to choose 3 numbers, fix everything else. So there's 8 choose 3 ways of selecting your 3 numbers. And then you can either spin them one way or you can spin them the other way. So I'm pretty sure it's that. Okay. And that's the end of section A. So now we move on to the optional section. So what I'm going to do here, I'm going to just flick through this. And I'm going to try and decide which of the... Ooh. Answer all 5 questions. So is there a part C? Oh, wow. Well done. It's all changed, isn't it? I swear to God, it used to be section A was all the mandatory questions, and then section B you could choose 3 from 5 or something like that.
Yeah, I mean, this is now a 3-hour paper. I think that when we did it, it was a 2-hour?
No, it was 3. It was 3 hours. All 20 credits.
3?
Yeah, 20 credits is 3 hours. You never really needed it, but you know. Okay. So I guess we're doing all 5 questions. What's Emily talking about there? So these are some of my friends from home.
Yeah, sorry, we're being a bit silly.
You're being a bit silly. That's not like you guys. So, right. So let P of n be a predicate. Describe this method of simple induction used to prove that P of n is true for all n naturals. Simple induction, as opposed to strong induction, which is a little bit different, even though they are actually logically equivalent. But simple induction says if P of 1 and if we have the case that P of k implies P of k plus 1, so if that is true, then P of n for all n natural. And obviously by 1, I of course mean the minimum value of the naturals. It could be 0 because I need to just say for the rest of this paper, n will be the positive integers because I think that's how they do it. So that I don't have to make the point absolutely every time. Let's just say that for the time being, and I apologize to whomever that may offend. Okay, use simple induction to prove that 2 to the power n minus 1 is less than or equal to n factorial for all n. And I've just noticed another donation there from Campbell. Thank you very much for your donation. Once again, all really helps. And even though we've exceeded the target, it's still worth trying to get as much as we can. So, what are we doing? Induction. Yeah, I mean, you can clearly see here that they're not treating 0 as natural because they're 2 to the power... Oh no, that still would work because 0 factorial is greater than or equal to 1/2. But there we go. So, base case is 2 to the power of 1 minus 1. Is it less than or equal to 1 factorial? So that's 1. And that's 1. Yes. 1 is less than or equal to 1. So now assume... This is, well, I was going to say it was a weird question to put since we've just done a further maths question which involved a much more difficult induction. However, that was on further maths, and most universities will allow you to do a maths degree without further maths. I think much to the chagrin of some of the academics at universities, but never mind. So assume 2 to the k minus 1 is less than or equal to k factorial for k, not an integer, sorry, natural. And then 2 to the power of k plus 1 subtract 1. Now what is that? That is 2 to the power of k, which is equal to 2 to the... times 2 to the k minus 1, which is Dan, yeah, no worries if you need to go, don't feel free. You've been here for many hours, and I really appreciate the fact that you've been here. So if you do need to go, absolutely no worries. If you're talking, you might be muted or something.
Yeah, I might just drop off for a little bit.
Yeah, absolutely.
I'll come back. I'll come back. I really wish that I could stay and watch the fun, like the actual, like, you know, higher level mathematics.
The capital
so interesting.
Capital M maths, but yeah, absolutely no worries.
Have fun. See you later.
See you later.
See you later.
So this is less than or equal to 2k factorial by induction. So that's our inductive assumption. We've assumed this, so we can use it here. And now this is certainly less than, because we're trying to introduce k plus 1 factorial here. This is less than or equal to k plus 1 times k factorial, as 2 is less than or equal to k plus 1, because k is a natural number, so that this is certainly true, which equals k plus 1 factorial. So therefore, by induction, result holds for all naturals n. Right, next question. Completely switching gears here. Right. Oh, this is like my second ever video where I talked about functions and things like that. So let f be e to the power x. Let g be reciprocal of x squared. Write down f composed with f. So g of e to the power of x is equal to 1 over e to the 2x. And since we've composed them, domain is the reals, because we've mapped from there, and then we've gone over to the codomain is the positive reals. Is that a surjection? I think it is, isn't it? Oh no, is G circle? It is yeah. So oh yeah, this is the one that we found. Let me just write that. G composed with F is equal to of X is 1 over e to the power 2x. And this is a surjection actually, because the codomain is just the positive reals, and 1 over e to the 2x. Oh god, what does it actually look? I think it looks something like that, isn't it? Because it's the like reciprocal of the exponential. So I think it kind of looks like that. I think like big negative is going to make negative power, which is 1 divided by a tiny number, which is going to be a big number. I think it looks something like that. So I guess to prove that it's surjective, if we let y be a member of the codomain, then choose x equals something, and I'm gonna, because we want it to be such that this happens. So basically anything that we choose in here, there's something in the domain that will hit it. So if we do 1 over y is equal to e to the power 2x, then 2x is equal to the log of 1 over y. So yeah, so if we choose x is a half log 1 over y, which is a real number, for all positive y, remember, because you can log anything that's positive. So this is fine. This is fine. So it is a surjection. Okay, B7. Need more paper. Define what it means that a set is denumerable. This is one of those funny words that you see it sometimes. I saw it early on in my in my degree, but didn't really see it much after that. We usually say countable. So A is denumerable, if I could spell it. If and only if there exists f from the naturals to A bijection. Prove that the even set of integers is denumerable. So if we do f of n is equal to 2n, this is a bijection, and to prove that, we'll prove injectivity first. So we'll say if f of n equals f of m for naturals n and m in there, this implies that 2n is equal to 2m, which implies that n is equal to m, so it is an injection. And then it's a surjection, because let 2m be an even number. Well, be even. Well, m in there. I mean, 2m is obviously even. Then f of m is equal to 2m. So it's a surjection. It's hit. Everything gets hit. And there we have it. So
I've got another donation from Campbell, £10.
I actually already thanked Campbell. Not that we shouldn't thank them again, but
Oh.
I did cover that one. But thank you. It's better to thank twice than not thank at all. So let's
I have one job.
You have one job. Yeah.
Difficult over here for me. I'm doing some really challenging work.
Yeah, well, I know you've joined at a funny time, really, because like no offense, like this is probably the least the paper that you know the least about, because you're a chemist, Whereas I think like the GCSE and stuff and the A level, you did A level maths obviously. It's like you do remember some of that. Whereas this, I think is
alien to me.
yeah. I should explain a little bit more about what I'm doing, but I also don't really want to because I am a little bit behind time.
Yeah, all good.
Although I've still got some of the easier papers. I'm not worried that I'm gonna miss it, and I can go into speed mode. I think if I need to on the GCSE papers for sure. Right, so equipotent. This means that they have the same cardinality. So A and B equipotent if they are of the same cardinality. Now, let A and B be sets. Prove that if A and B are equipotent, then B and C are equipotent. Oh, sorry. If A and B are, and B and C are, then A and C are. Well, maybe the definition it wants me to use is this. A to B, so there exists F, A to B bijection. You may use, without proof, any properties of functions. So I'm going to use the fact that if F, G bijections, then G circle F and F circle G are bijections. I did this at the end of my second ever video where I had that diagram with the arrows going across the diagrams. I don't know if you remember back that far. It was about a year ago actually when I made that, almost exactly a year, because it was recently the 1 year anniversary of the channel.
Yeah, I saw that. Yeah.
So yeah, I remember doing this whole diagram, like lots of green arrows and stuff like that. Always tried to make practical things to illustrate the theory. So I'm going to use this property, and I think that's the only property of functions that I need. So if F from A to B is a bijection, and G from B to C is a bijection, we know that they exist because as A, B equipotent and as B, C equipotent, so we know that these functions exist. Then if we do F composed with G is a bijection using the result stated above, therefore A, C are equipotent. Prove that the open intervals 0, 1 and 0, 10 are equipotent. So this is like one of those weird things about the real numbers. There's the exact same amount of numbers between 0 and 1 as there are between 0 and 10. So F from 0 to 1 into 0 to 10, defined by x is mapped to 10x, is a bijection. For pretty much the exact same reason as the earlier one was. So again, we'll just do this kind of if f of x is equal to f of y, that means 10x is equal to 10y. Therefore, x is equal to y. So this proves that it's injective. And then for all y in there, choose x is equal to y on 10. Then f of x is equal to 10x is equal to 10y on 10, and therefore is y. So every possible thing you could find in there, you can find something that will times by 10 to hit it. I suppose another way of doing that is we could have just said it has an inverse. So f inverse of x is equal to x over 10. And as we know, bijections, they have inverses and vice versa, if and only if. Okay, a comment about A4. What was A4? Not answered correctly. I don't want to keep doing this. If I've made a mistake, I need to kind of make peace with it. But I also want to just check to see what they were on about. Oh yeah, in fact, having read this, now that I read it again, yeah, I actually see exactly where I've gone wrong there. Is it possible for that to be a prime number? What I did was I found, so I thought the question was saying something slightly different. I did misread that. Okay, so this is a good point actually. So I I said that because phi of 10 is not prime, the statement is false, which is just a total misread from me. So is it possible for that to be a prime number? Can it ever be the case that that phi of something like that is prime? 515. So how many are co-prime with 15, for example? Just to get a feel for whether I want to try and start trying to prove this true or false. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 1, 2, 3, 4, 5, 6, 7, 8. Feels like it might be. Oh wait.
People mentioning 5, 6 equaling.
Yeah, because
what you mentioned.
yeah, we said that earlier, didn't we? So yes, it is possible. So basically, I kind of proved that. Well, I was thinking about the opposite statement really. I was saying I thought it. Yeah, I just misread it. I answered the question: is it possible for it to not be a prime? And so it's not really the inverse or the converse of the statement. It was just the wrong thing. So yeah, thanks for pointing that out because yeah, I think that was a fairly easy question really. So it should be one that I was getting right. Right, let's continue with the B7 then. So B7 part 3, we have got. Oh, see, there we go. See, this is interesting now because the GCSE has this literal thing on it. So why we are doing it at this level is kind of beyond me. This is a waste of 2 marks. You could be answering a much more interesting question here. Anyway, we all know the game. So let's do 4, 5, 7, 4, 3. Okay, so this, we let x be that. And then we've times this by 1,000, I think. 1, 2, 3. Yeah, so this is 1,000 x is equal to that, and then we subtract, so we get 999x is equal to 345.4, and then the recurring parts die. So now we have 999 times 10 is equal to 3454, and divide. And let me just see if that simplifies. 3454 divided by that. Looks like it'll divide by 2. Yeah, 1727 over 4995. I could have just written it unsimplified actually because it's not asking for it in lowest terms, but there we go. Right then. Oh, we've got a donation from Emidio. Is that how you say it? I hope I'm pronouncing that correctly. Thank you very, very much. And I absolutely love what you did there, which is to bring up our weird total up to a nice clean multiple of 10. So thank you for your donation, and thanks for your what am I trying to say here? Your passion for multiples of 10. Because I think that looks a bit cleaner. I think actually one of the first donations I ever got ended with 0.21 or something, because it was a Rush reference 2112. Yeah, so it's something like that. And I think that threw it out of whack. Doesn't really matter. Oh, I also had a donation of like a multiple of pi, so that was nice. But also kind of nice to see it a little bit more evened out. Anyway,
I'm going to donate a penny now.
I knew you were going to say that. Yeah, and then someone has to
see how far I can take it.
Yeah, someone has to donate 99p. That's tactical. So B8 part 1. This is going okay. I am scared that there's going to be something on here that I might be the odd theorem that I've forgotten or whatever, but at the moment, oh, so here is where we might get a bit stuck. Because I know what this is Diophantine equations, which was never my strongest suit. So, prove that. So this is a well-known result, and I really ought to know the proof of this. Right. So if x naught, x naught, y naught, if they are solutions, yeah, this is how you derive the general solution. But boy, I don't know if I remember how to do this. This might be a question that I have to skip or something. I don't know. Let's see what happens. So I do remember. What is it? Is it Bezout's theorem? Which is like. Sorry, if we let D be the greatest common divisor of A and B, then there exist n and m integers with na plus mb is equal to d. That much is true, and I'm sure it's got something to do with this. What else do we know? We know that ax naught plus by naught is equal to c. And I'm sure that this has a solution only when c is some multiple of d. So I'm going to write c is equal to kd. And we'll go from there. Which means kna plus kmb is equal to kd, which is c. Oof, I don't have a good feeling about this. I think I've forgotten how to do it. Oh God, it's like trying to remember a word. You know, if it's on the tip of your tongue. I definitely remember doing this. Has it got something to do with that? So if we do, maybe you get what? Oh God, it's like I can almost feel it. N, I don't know, alpha plus m beta is equal to 1. And alpha and beta are integers here because d divides a, so a over d, and b, because it's a divisor, it's the greatest common divisor, so these are in fact integers, so that's fine. I'm sure, God, I'm sure it's got something to do with this. Let's not introduce that notation because it's horrible, and also it wants something like this. So if I do n a over d plus m b over d, this equals 1. N ac over d plus m bc over d is equal to ax naught plus by naught, because what I've done there is I've multiplied through by c. Now, God, I'm struggling on this one. Struggling on this one. I can't remember how you do it. I think I've got the right pieces. The board is set. The pieces are in place. The pieces are moving is actually the quote there. Just in case someone.
You're also getting you're getting no comments in the chat either, so I think.
Well,
I
yeah,
think
that's that.
everyone's-
This is shut everyone up, isn't it? Yeah. So this is well, this is a standard result. Because basically what we're doing here is so obviously if you've got something like 3x plus 4y equals 5 or something like that, then there are an infinitude of solutions to this, because whatever you choose for x, you can rearrange it and solve for y. However, if you make the specification that x and y have to be integers, it suddenly becomes harder and it suddenly becomes very different, and that's what a Diophantine equation is. So named after Diophantus, one of the ancient Greeks. So it's basically equations of this form, but you're restricted to the integers. And then the way you solve them is you use Euclid's algorithm, and then this gives you, once you've got one specific solution, you can then derive the whole general solution. But I am struggling to remember how you do it. It's got to be close here, right? So x naught minus nc over d lots of a plus y naught minus mc over d b equals 0. Just trying to get it into something that looks vaguely like this. I've got x associated with b, and I've got y associated with a. This is tricky. This is tricky.
The donation from Emily and Josh.
Oh, absolutely fantastic. Thank you very much, Emily and Josh. And of course, you've just ruined Emilio's great work there. I knew that was going to happen.
Some people just want to watch the world burn.
Some people, yeah, yeah. Particularly, I think Emily does want to watch the world burn right now. I wouldn't put that past her. Right.
Donating to a mental health charity, you monsters.
Yeah, that is watching the world burn, isn't it? AX plus BY equal to C. AX naught plus BY naught. I'm just trying to work backwards here, just based on a comment I've seen from Kat. So this is interesting. So yeah, we get A x naught minus x plus B y naught minus y is equal to C. Then what? Is equal to 0, sorry. That's the whole point of that. not forget this. I'm sure it's called Bazoot's. Is it Bazoot? It's one of them. Is equal to D. Because we do need to get the greatest common divisor in there somewhere. I might divide through by D. All right, thanks for joining, Emily. Really thank you for all the support, and thanks for helping me out with that video as well. I really do appreciate it. Yeah, I should eat soon. I've not eaten for a while. And make sure you get lots of rest as well. So, yeah.
Another comment from Kat, which might be helpful.
Yes. So they have the same ratio, but I don't know how that's. God, myself from 3 or 4 years ago would be like screaming in his chair right now. It's so annoying because this is the kind of thing that when you do a maths exam, you just memorize stuff like this and you just do it. I might have to give up on this one because I'm hemorrhaging time here. But God, I'm sure I know this. I hate to leave a question unanswered, especially like a standard one like this.
Can we come back to it?
Don't think prime. It's a good idea, but I don't think prime. There's a way to do this. It just clicks together. Oh God. My brain remembers this for some reason.
Couple more comments.
Yeah, the coprime, which is basically what this is saying. Ooh. Something about that just struck a. A over D x naught minus x equals b over d y minus y naught. This is interesting actually because a over d is now divides this. So a over d, which is an integer, divides y minus y naught. Because a over d and b over d are coprime, it must be the case that have we used k yet? Kind of. Let's. Oh god, what other friggin' how many letters are we gonna have on here?
25 donation.
Thank you very much. Oh god. Lyuboslavolov. I really hope I'm pronouncing that even remotely correctly. Thank you very much. Really appreciated. So a over d times p, not a prime p, is equal to y minus y naught for some integer p. And how does... God, it just feels so close. Honestly, it's infuriating. So a over d x naught minus x is equal to b over d times a over d times p. If we times through by d now, maybe I don't know if this is right. A x naught minus x is equal to AdP over D. Divide both sides by A. X naught is equal to x plus. What's happened here? That's a B, isn't it? BP over D. And that's it. That's it. Except negative. But it's okay, because I think if we do this for y now, we would get y negative. I think it's good enough. I think, yeah, so because this is I've used p, but this has become our t. Yes. I think y naught will become y subtract AP over D. This is left to student. I think if you do it, because the way I've done it, I basically had a choice up here somewhere. Either write x naught minus x here, and then y minus y naught on that side, or x minus x naught on that side, y naught minus y on that side. I think if you just multiply both sides by -1, then you get the relationship in the question there. So, right, well, I think we've done it. I think we've done it. I think this is good enough.
Well done.
Oh, wait, no, actually, what am I talking about? X is x naught subtract b over d, lots of p. And y equals y naught plus, so it is the right way around. A over d times p. So, that's it. Cheating a little bit here, but screw it. I think that's good enough. I think that's good enough. I think I spent long enough.
Yeah.
Should have just given up on it, but I knew that it was in there somewhere. Well, it wasn't really, because I needed the help of. Thank you, Kat. That's really, really appreciated. Really, really helpful. Because I was really struggling there. I think at a time I could have just written that in about 30 seconds, but yeah. So now assume that A is 0 and B is not 0. Is it still true that if this is a solution, then xy is given by that formula? Well, if A is 0, then we've basically just got by is equal to c, therefore y is c over b. Specifically. So there's only one solution. So surely it's not going to be the case. Actually, maybe it is. Because xy now, if we want a general solution, is equal to this one specific solution minus b over, well, the greatest common divisor of a and b when a is 0 is just b. T y naught and plus 0. And x can be, yes. So basically we'll say x naught subtract t, y naught. So this is our specific solution. That's the only thing we're allowed to do for y, but x is actually allowed to be anything. So this here, the set of all x naught subtract t, such that t is integer, is the set of all integers. And that's fine, because x can be anything, and it still doesn't ruin this equation. So strictly speaking, yes, I would say yes, it is still given by that formula. Which is a weird question, but I suppose it's just probing about generalization. Oh, this one is going to be nice, I think, because this is more in my wheelhouse than all the number theory and stuff like that. So let the relation twiddles, that's what we all say in the maths world, defined on the set as follows. A twiddles B if and only if that. So A is related to B if and only if 4 divides 7a cubed plus b cubed. Okay, So prove that it's an equivalence relation. So we have to show that it is. Oh my God, I'm blanking on the word. There's transitive, symmetric, and reflexive is the other one. So is it reflexive? Well, is A related to A? Well, 4 divides 8A cubed, so yes, it's reflective. Now, symmetry A equals B implies 4 divides 7A cubed plus B cubed. And now, let's interrogate 7B cubed plus A cubed. Well, this is equal to 7A cubed subtract, plus B cubed, as long as we add in 6B cubed and we take away 6A cubed. It's not what I wanted to happen. I didn't want 6's, I wanted something else. 7B cubed plus A cubed. But no. Because what I want to say is this 4 divides that, but I really hope this. I really wanted this to just fall out. Oh, come on, I really. This should be easy. The only way I can see of doing it is to say, so this is a multiple of 4 by the assumption up there, and now this must be the case that the difference of 2 cubes is always even. So this is 2 lots of, this is 6 B cubed minus A cubed. Now, A even implies A cubed even. B and A odd implies it's not the case that the difference between 2 cubes is always even, though. What am I not getting here? What am I not getting? Because this is stupid. I really should be able to do this.
There are a few comments now if you did want to take a look.
The difference of 2 cubes is always even. Well, I don't think it is, because what about if you choose like 8 and 1? That's 7. This is what I thought. I thought that must be it. But I suppose it's based on the fact that this that this is even. So it must be the case that we've either got odd. So for A and B, we've either got odd, or we've got even. Okay, so they do have the same parity because 7A cubed. So if that's odd, then this whole thing is even. Oh, no. No, sorry. If that's odd, then this whole thing is odd, which means B must be odd. They can't have different parities. So, yes. So, let's just say I've kind of done it verbally. This is always even. I just thought it'd be easier than this. So, therefore, B cubed minus A cubed is 2k, and then 6 of 2k is equal to 4 of 3k, which is a multiple of 4. God. I really thought I'd enjoy this question, but that, and then transitivity, that's supposed to be a T underlined, not an I. So A is related to B, and B is related to C. So that means that 4 divides 7a cubed plus b cubed. And then 4 divides 7b cubed plus c cubed. And now we need to think about 7a cubed plus c cubed. Right. Why must 4 divide that? Well, this is equal to 7a cubed plus b cubed plus 7b cubed plus c cubed. Now I've created 8. This one's easier. And then that is a multiple of 4. This is a multiple of 4. And obviously 8 times something is a multiple of 4. So it is an equivalence relation. Show that the equivalence class of the integer 0 is the set of even integers. So suppose, let's do it this way around. 0 is related to n. Then 4 divides 7 lots of 0 cubed plus n cubed. And 4 divides n cubed implies n is even, as we've seen, because it implies that n cubed is even, which implies n is even, because we saw before, well, I kind of explained, if you cube an odd number, you get an odd number. So, like, 3 cubed is odd, etc. And that's, you can prove that if you do 2k plus 1 cubed, you get an even number plus 1. So yeah, if n is odd, then n cubed is odd. Therefore, if n cubed is even, n is even. So that's fine. So if n is related to 0, it is an even integer. Write down without proof one other equivalence class induced by the relation. Well, I'm tempted to say the odd integers, but I'm not sure about that. I'm not willing to say that for certain. So 1, suppose 1 is related to n. Then 4 divides 7 plus n cubed. So for example, n is 1. But what about n is 3? 3 cubed is 27 plus 7. Yeah, it's not. So n equals 3 doesn't work. N equals 5. 125, that's 132. Yes, that works. So I'm going to guess that the equivalence class of 1 under this relation is the set of integers n such that n is congruent to 1 modulo 4. That's what I'm going to guess is happening there. I suppose we should prove that. Oh no, write down without proof one other equivalence class. Yeah, I think that's fine. Okay, and the last question. Okay, question 1, give the definition of a prime number. That's another video I made a whole topic about. My worst performing video ever. But I really, really liked that one. I thought I really enjoyed making it. I did so much research, and I really, really enjoyed going into my old university library and getting out all those old books and actually finding historically why why one was considered to be different in many different parts of history and parts of culture. So a shameless plug for my own content there, but if you haven't watched that one, I did enjoy making that one, and I thought it came out really well. So definition of a prime number, I think we'll just say this: n greater than 1, obviously an integer, such that n has exactly 2 factors, or divisors, we might say. Okay,
I'll be back in 5 minutes. Okay.
yeah, okay, no worries. Deduce from the definition that every prime number p has the following property. For all integers a, p divides a implies that a and p are coprime, or, oh, sorry, or p divides a. So a being an integer implies either it's coprime. Well, let's assume the greatest common divisor of a and p is not 1, i.e. k, not 1. So then k divides a and k divides p. But this implies that k must be equal to p, because it's the only factors of p are 1 and p itself, and we've already said that k can't be 1. So, therefore, p divides a. So when it's not the case that they are coprime, then a is a multiple of p. So that's actually sufficient for the proof. Okay, so let p be the set of all prime numbers. Prove that there exists a subset of the primes Oh, I've skipped a question there. Thank God, because that looked like an absolute nightmare. Is there a non-prime number p which has this property? Well, I suppose 1, because if you are... because if you're an integer, then 1 divides a. So it does have the property that it's either that or that. I mean, it's always that, but for an or statement to be true, then only one of them needs to be true. So that's fine. Now, this... I need some paper for this. What on earth is going on here? So this is saying basically that the product of a few distinct primes, so it's basically saying there exist p1, p2 up to pn, such that p1, p2 all the way up to pn is congruent to 1 modulo 2 to the power 99, and that n is greater than or equal to 1 and less than or equal to... Holy moly. Well, what do we know about primes and congruence? We've got the old Fermat's little theorem, so that a to p is congruent to a modulo p, provided that they are coprime. Oh, but that's to do with powers, though, isn't it? And they're all distinct. What else do we know? So that's Fermat's little theorem. There's also, I think it's Euler's theorem, which is a bit of a silly name for a theorem because I bet he has about 100 theorems. And I think that is a to the power of phi of n is congruent to something. But again, we're taking powers here. So Euler's theorem. And then there's also the Chinese remainder. I actually can't remember what the Chinese remainder theorem is, but it's got something to do with... God, I only remember it for rings. Can I backtrack what that means for the integers? Oh yeah, Spoof, you're suggesting the Chinese remainder theorem as well. What is the Chinese remainder theorem? I know it's got something to do with like if A and B are co-prime, then AX and BX. Oh God, what is it? It's a condition by. Is it that AX is congruent to B mod? Oh, it's something like that. It says when solutions exist. Well, this isn't the Chinese remainder theorem, but this is. I think this is a fact. Sorry. Then the has solution. I think there exists a solution when A and B are co-prime. Maybe we use that because if we say because P1 is congruent. So P1 times X is congruent to 1 modulo 2 to 99. Has a solution X. And then is there a way of like constantly peeling out this? God, this is hard. Okay, no worries. Yeah, okay. Well, I'll be honest, guys. I don't even know where to start in this one. I think there's some theorem that will be taught in this course that I don't know what it is. Anyone in the chat there? Well, that's an interesting thought there, Malignus. I think is yeah. So if there does exist a prime, however, 2 to the power of 99 plus 1, in fact, is not prime. This is not prime because the only prime if 2 to the n plus 1 is prime, then n is a power of 2. This is one of Fermat's results, I think. So it's not prime, which means it does have a factorization, but it's why are those factorizations distinct? And also, well, it might not be, but we do know that there's some multiple of this plus 1 must have a factorization into distinct primes. Don't you have to prove that there is such a prime of P1 that has multiplicative inverse? I'm looking at nobody in particular. I mean, literally, sorry, they're called nobody in particular. Don't you have to prove that there is such a prime number P1 that has a multiplicative inverse? Yeah, well, that would be good because if there exists a multiplicative inverse, then whatever that is, we'll take it to be this here. So then P1 and then its multiplicative inverse, I'll say in kind of in brackets, will be congruent to 1 modulo 2 to the power 99. But I can't remember the conditions by which. No, Mersenne primes are 2 to the n minus 1, unfortunately. So Dirichlet, a prime for every arithmetic progression that can have prime. Yeah, I don't think it's. Yeah, no one in the chat able to. Oh God, I genuinely, I don't even know where to begin with this. Well, unfortunately, no, because 2 to the power n plus 1, it's composite, which means it does have a prime factorization, but we don't know if they are to powers. So it could be something that looks like that. Oh, I've used this bad notation. Let's make them m's. Okay, so all primes apart from 2 are co-prime with 2 to the 99, I agree. So they have multiplicative inverses mod 2 to the power 99. But is that inverse a prime? Now that I think about it, let's just start a new. Yeah, we're struggling on this one on Creamer. I've got absolutely the chat's really helping me out here. So, let P be a prime that's not 2, then P, then there exists an integer Q for which PQ is congruent to 1 modulo 2 to the power 99. But the question is, why must Q be prime? I feel like there's some argument that would allow me to kind of keep repeating this process, and I want to like peel it out into because there's nothing to say that this is prime. I just don't know, and this is freaking me out as well. The only thing I can think of with that is what happens if we times together all the primes. If we multiply together P1, P2, all the way up to P2 to the 99, what happens when you multiply all those together? Is that guaranteed to be congruent to 1 modulo 2 to the power 99? Apart from 2. So starting with P1 equals 3. But I don't know how we would do it. I really don't know. I think this might have defeated me, this one. Certainly after 11 hours, I'm not gonna have a burst of inspiration here. What do you think, Creamer? Sorry.
No. I think you're not expecting to get completely full marks and everything, are you?
No, I did. I said I was aiming for around 100%, but like, I mean, I certainly got a first on this exam. But you know.
Exactly. Yeah, this is university level. No one's expecting 100%.
Yeah.
All right, we'll just end the stream there then. We're done.
No, we're not done. Yeah, I mean, I don't want to go down this rabbit hole because people are suggesting like, what if you choose a smaller power of 2? Can you find 3 primes? Well, a bunch of primes. So, what if we do the first like 8 primes, for example, 3 times 5 times 7 times 11. Well, 3. What's the inverse of 3? So 3x is congruent to 1 modulo 2 cubed. So 3, if we want 3 times something to be equal to 8n plus 1. So x has to be even. So if we start with 6, sorry, what am I doing? No, x has to be odd. So if we do 3 and then add multiples of 6. Oh, but again, how do we, so 3 times 3 is congruent to 1 mod 2 to the power 3, but that's not what we want because we've duplicated a prime here. That's bad, that's bad, that's bad. Okay, 3 times 11 is congruent to 1 modulo 2 cubed. I don't like induction for this because there's no obvious bridge between like your inductive assumption and the inductive step. It's killing me. Just trying to read Cat's comment there. So maybe something like for each prime p, you multiply into the product, you change the product mod. I think what Cat's trying to say is like 3 is obviously congruent to 3 mod 2 to the power 99. And then if we do 3 times 5, it's congruent to 3 times 5. So we're constantly ticking through all of these numbers here every time we multiply by a prime. And the number of options of the number there, it has to be a number between 1 and 2 to the power 99 minus 1. And I think as long as they don't repeat, you must eventually get 1 somewhere when you are multiplying all the primes like that. So somewhere along here, as long as you don't get a repeat. But if you get a repeat, then surely that's a contradiction somehow. So if we imagine, for example, we've got a whole bunch of primes times together, let's say k is congruent to r mod 2 to the 99. And then we have p1 up to pk up to pn congruent to r mod 2 to the power 99. Then this is a contradiction because if we do this divided by then p to the power k plus pk plus 1, I'm thinking so fast I can't even talk, is congruent to 1 modulo 2 to the power 99. So if there's a repeat, we can generate them. If it doesn't repeat, it has to get to 1 eventually. Are we happy with that? Wow, Kat, I mean, you should have been answering this paper, to be honest, because so are we okay? Do we think this is a good? I mean, obviously, I've been quite janky in how I've written it down, but the argument goes like this: every time you multiply by a further prime, you are changing the residue here. So therefore, every time you multiply, you change the residue. there are only 2 to the power 99 minus 1 possible residues. Eventually, if we are going to multiply all of the first 2 to the power 99 primes together, either we hit 1 eventually, in which case we're done. If we don't, well, how could we possibly not? We must have had a kind of formed a loop. And if we form a loop, then actually what has happened is we can do this group divided by the first group, and that equals 1. That is congruent to 1 mod 2 to the power 99. So, I think that is true. Well, because, Harald, we are multiplying the first 2 to the power 99 primes. That's why in the question it says that the set that you're multiplying is less than 2 to the power 99. So I think that actually does it. Wow. What a great, well, I think all credit goes to Kat there. Very, very good. And I'm actually, now that I've seen it, yeah, you're right. It is a little bit like the proof of Fermat's little theorem. That kind of this clockwork, you eventually start to repeat yourself. Yeah, and actually this makes a bit of sense. And actually, this is the way I should really have thought about this, because again, I'm usually a finite. This is the kind of I don't say it's the group way of doing the group theory way of doing it, but like this proof by kind of exhaustion of all these possibilities. That's usually the natural way I try to go on these sorts of questions. But alas, that is it. So, Kat, I owe you a massive, massive thank you. Thank you for that, because that was 2 questions I was really struggling with there, and I don't think I was ready to give up actually, even though I would have absolutely hated myself, and I would have been metaphorically self-flagellating for the rest of the night, because I hate to leave a question unanswered. So that concludes our journey of mathematics. We have done 10 papers in 11 hours, but we've got through the degree level paper, we've got through the further maths paper, so we've got through some tricky papers there. I think I need to eat something, actually, because I haven't eaten since like 4 p.m. So give me another 15 to 20 minutes or so. I know I had a break, well, it was about 2 hours ago now, but yeah, if you give me about 15 to 20 minutes, I will be back, because I really should eat something, because it's probably why I'm getting a little bit frustrated and cranky as well.
You've got a donation, just £20 donation from Sydney.
Oh, Sydney, thank you.
I'll mention that before you go.
Yeah, thank you. Yeah, thanks for that, because I really do want to make sure that I thank everybody who does donate. So thank you very much, Sydney, for that donation. That is absolutely wonderful.
What's the next paper?
Now, the next paper, we're going to do the International GCSE. So that's like just a little bit of a step up from the GCSE. So it's not as hard as A-level. It's not as easy as the... sorry. It's not as hard as the A-level. It's not as easy as the GCSE. It's a little bit of a middle ground between the GCSE and the A-level. Just there's a little bit of calculus on it and things like that. Nothing too crazy. So let me find my chalk. So what should we say? 23:20. I'll give myself like about 19 minutes. That should be enough to get some food and stuff. Because I do want to get back at this, because we are, quite below time. So let me fill in what the next paper is going to be. Thank you very much for everyone who's still with us, by the way. Love to see so many of us in the chat.
Yeah, amazing.
Especially when I can't answer the questions, it's always really helpful. So, exam 11, it'll be an International GCSE paper 1. So look forward to that. I'll be right with you shortly. So I'll just stick that in there, and I'll be right back.
Cool.
Hello, hello.
Hello there.
What have I missed?
He's just done a first year degree paper.
Was
Um,
the sets, numbers, and functions, or whatever it's called these days?
I think so. I want to maybe.
Well, I think I saw a little bit of modular arithmetic going on at the end there.
Oh, that seemed like a real struggle.
Oh, it's really rough. Yeah, really rough.
But I guess it's just a lot of it is memory based as well, right? You need to sort of.
Oh dear, we're getting a bit of feedback there, Adam. I think.
Really?
Sorry, apologies. Problem on my end.
Okay.
Absolute amateur. Sorry about that.
All good, all
Sorry,
good.
you were saying he's just done his first year degree paper. He was doing further maths before that. The further maths papers are absolutely monstrous as well.
Yeah, it sounded like it was a real slog, but I wasn't there for that though.
Oh, okay.
One paper so far.
That was tough as well, was it?
Yeah. A lot of help from the chat, which is great because I can't. I honestly, that was like a different language to me. There's so much like base knowledge that's needed to understand that paper.
Yeah, and I think the other thing, which I always think with the further maths papers, is there's a lot of time pressure. So even, obviously he's trying to do these things even faster than you would do them in real exam conditions. But the further maths paper, I think it's a 90-minute thing, and I think it's really rough to get it out, a lot of it.
Yeah, I remember you saying, especially because when you get caught up on a question that you're frustrated at because you know that you can do it. You can get into your own head in exam conditions, can't you? Where it just becomes like just so frustrating.
Yes, you're trying to, catch your white whale or whatever.
Yeah. So have you joined earlier today then, I'm guessing?
I popped in the last time we were having a bit of a chair stream as well. So I thought I'd come back this time. I'm going to be back in. Sorry. Yeah, I'm coming back in the early morning, so I'm going to be back at in about 4 hours. I think I'm going to have a quick bit of shut eye, and then I'll come back.
Oh, good commitment, getting up at the
crack of dawn.
Early. Yeah.
Yeah, well, of course, for the we got an international audience today, so it's not the middle of the night for everybody, I guess. But
yeah,
it will be for me.
Yeah. No, it's amazing. I asked the question of where people were from, and it's all over. It's great.
Well, this is the beauty of maths, right?
It's it. It's still, universal language.
Louise asking what sadist thought of this. I actually don't know whose idea this was originally. I suspect it was probably Alex's idea originally.
Yeah.
But believe it or not, I think he actually enjoys this, and I have to say I always find it pretty entertaining as well. I mean, it's very interesting, just from a kind of like pedagogy perspective, to look back. What just to compare like what stuff they have in the GCSE that they don't have in the A level. How the different syllabuses are different, how the papers change. I can see he's put on that we're about to do an IGCSE, which actually is kind of interesting because the IGCSE I think has converged, or rather the GCSE has converged with the IGCSE. It used to be very different. I think they're.
All right. Okay.
Yeah, I think they're getting increasingly similar these days. Because in the old days, probably you did a similar GCSE to the one I did, where you had to do coursework.
That's a good question. I think I remember. But maths coursework sounds like. I don't remember doing any maths coursework.
I mean.
Well, what kind of thing would it be?
Well, you see, you're getting me onto one of my favourite subjects with that question. So basically, around the late, the end of the noughties, most of the maths syllabuses were about 20% in GCSE. They're about 20% coursework, and in the coursework, it was usually some sort of investigation. So, for example, the absolute classic one was a thing called, I think it was called T numbers or T sums. And basically, the idea was you have just like a 10 by 10 grid of numbers, like the kind of, you almost like you see on posters in a primary school, sort of like 1 to 10 on the first row, 11 to 20 on the second row, or 1 to 9, sorry, and then 10 to 19 on the second row, and so on. And you just draw a T shape on there, add the numbers that are within your T shape up, and then you're making a hypothesis about, the relationship between the number in the top left and the sum and this kind of thing. And you can make some hypotheses about the patterns, and then what they want you to do is try and generalize it with some kind of algebraic expression and kind of justify, so that was what you had to do.
Okay. Interesting.
Yeah, but so that was 20% at the end of the noughties, but actually around the turn of the end of the 80s and the early 90s, there was actually a specification which was produced by an organisation called the ATM, the Association of Teachers of Mathematics, which still exists, and that specification was 100% coursework.
Oh wow!
Yeah,
that's kind of unimaginable now.
Yes, how the pendulum swings. 30 years we've gone from 100% coursework to 100% exam for 16
Is that
year-olds.
because of a rejection of the idea of being good under exam conditions, or was it like is there a pre-80s where it was a lot more exam based?
Well, yeah. So prior to the GCSE being introduced, so
the O level.
Yeah, the O level, of course, was was an entirely exam based thing.
Yeah. Okay. So there was a sort of a decision made where they decided that exams were an unfair sort of test of your ability.
Yeah, I mean, to be honest, I don't know exactly what the drivers behind it were, but yeah, I think you're right that I think there was an idea in the sort of 70s, 80s that about how really what does it really mean in an exam, to boil down 2 or 3 years of a course into 3 hours of exams or whatever.
Yeah, I often think about that with my university exams. Like everything came down to. Well, sorry, that's not true. Maybe 80% of my university degree came down to a week. A week and a half of exams, like all back to back.
Mm.
And it's just like if you just have a bad week, you're a bit unwell. You know what I mean? Like it's so sweet, so on the balance of just like a bit of luck in there as well. And also if you're just like me, where you're not exactly great under exam conditions, like it's really hard. Like it's it's quite brutal.
Yeah, it's a high stakes system. I mean, the counter argument to it from a sort of social mobility perspective is, of course, it's a lot easier to stop people cheating in an exam.
Yes. Yeah, especially now with the AI tools that are available and stuff like that, where you can quite quickly get an answer to a quite complex question. Maybe not necessarily. But you probably do have for maths, but obviously that's a bigger issue for like essay writing and things like that. But yeah, I do understand that.
Yeah, so it's interesting. I mean, but again, there are people. So there's. I haven't actually gotten around to reading it yet, but Stephen Wolfram.
Yeah,
like the Wolfram Alpha guy.
Yeah. I've watched it. I think I watched a bit of an interview with him recently. I feel like I've seen an interview with him on like Lex Friedman podcast or something. Maybe I'm getting that wrong.
Really? Yeah.
Yeah.
I'm sure. So he has put a book out recently, I think, which is about sort of, I think, his thoughts on the future of. Well, I think he's more interested in computer science, but I think it kind of overlaps quite strongly with maths. The future of what that kind of education should look like, and he's very much about it's about this kind of computational thinking and again, kind of investigation and exploration. And I really need to read the actual book, but sort of reading the blurb about it, I was thinking, gosh, this doesn't half sound like the 90s again, but
Right.
just with more computers.
Yeah. Yeah.
Or better computers, let's say.
Yeah.
Um,
Yeah.
So, yeah. Oh dear.
So do you? I can't exactly remember your. Do you teach? Do you teach math now?
Oh no, I haven't taught for a long time.
Been taught for a long time. Okay.
It's almost 10 years actually.
Okay.
But yeah, I've been working for pretty much a decade now in the NHS.
Oh, right. Yeah. Okay. Cool.
Yeah, doing data stuff. So to a
Yeah.
greater or lesser extent, doing statistics really.
Okay. Okay. Awesome.
And again, for our international listenership who might not know about the NHS, so in the UK we have this thing called the National Health Service, which is kind of provides for 90% of the people in the country, provides their healthcare, and it's funded through general taxation, so it's not an insurance system, and it's free at the point of use. So it's quite a different setup to, I think, what we have in most parts of the world. But the thing, of course, about having it like that is, it does require a lot of statistics because it basically is a centrally planned system, and so yeah, that's kind of.
So are you doing the stats on related to I'm trying to think of the way of wording this. It's not is it about future decision making about what interventions are working and things like that, or?
Yes, so like quality improvement kind of stuff, process improvement kind of stuff. Also, just there's a thing called the annual planning round where basically you kind of trying to forecast what the demand is going to be and how much it's all going to cost to deliver.
Interesting. Yeah.
Yeah, so that is a very mature process. So that is a thing.
Okay. Interesting.
And then also there's a thing called clinical audit, which is a very data-driven process, and we also monitor things like I don't do this too much in my current role, but I have done previously, but there's a lot of work done monitoring things like mortality, that kind of thing. Population.
Yeah, I've seen it quite a bit on because I follow. I mean, I don't think it's NHS, but I follow Ben Goldacre's work. I don't know if you've seen any of his stuff, but when he was doing, he sort of became popular for doing the sort of bad science and calling out bad practices and whatnot. And he has quite an interesting behavior of GPs with certain medicines and things like that, and how long it takes for, in certain areas, how long it takes for a new intervention to come in. So getting rid of old practices, because a GP has maybe been doing the same thing for 15 years and maybe doesn't know that there's a new way of doing, prescribing X drug or whatever. And all that kind of stuff is really interesting because that now you can actually get that data and actually do some interesting sort of analysis of it.
Yeah, absolutely. And that pharmacy data is all open data. So I think actually anybody can get that and have a good time analyzing that, because I think that prescribing data is all open data. Perhaps a very niche hobby, but I think that data is all out there for people to look at. And again, that would be a good statistics coursework. Get the prescribing open data and find something out about it.
Yeah, for sure. Yeah, that kind of stuff's great. I do find that stuff really interesting when the diamond in the rough kind of thing, where you can really find some interesting stuff from lots of data like that.
Yeah, that's good. I'm interested to know, people in the chat, if you've got a maths related job, we're certainly interested to know about it.
Yeah, for sure.
We'd like to hear. And as well, I think we probably, you stop me if you've done this very recently, but of course, we should say thank you to everybody who has joined us. It makes it really special to have so many people with us. It really is the audience. Great. Yeah, it's really the audience that makes the whole. Well, I was going to say the evening, but it's really 24 hours. So the whole
Yeah, so
event.
this is not Alex's first live, obviously first maths live stream, but it's the first since he had his YouTube channel, so it's a completely different experience this time.
Yeah, it's really lovely.
Loads more maths based sort of help.
Yes, Clofat tutoring counts. Certainly. Does undergrad count? Yeah, well, I mean, it's not really a job, but yeah, we'll count it. It's a maths-related activity for sure. It seems to be quite a lot of undergrads here, which is awesome.
Yeah.
Yeah, that really takes us back. And of course, thank you to everybody who has donated to Mind as part of tonight. It's an awesome charity.
I'm amazed by this £1,000 donation as well. When did that happen?
Oh, that was near the start. Yeah, absolutely wonderful.
Amazing.
But you know, every little helps.
Yes, of course. Yes. Gotta call out the big ones though.
Yeah, absolutely. And yeah, so yeah, every little helps. So thank you very much. And you know, it really is a charity that is touching the lives of hundreds of thousands of people, doing all sorts of diverse kind of work, running helplines, helping businesses come up with good policy and help people get into and stay in work. You know, providing all sorts of services, including crisis services, I believe. So really, really worthwhile cause to, you know, across the whole breadth of ways that mental health can affect people's lives. So really awesome. Oh, this is a good question. So Chloro King, is it possible to learn all mathematics? Now this is such a great question because it opens up it's such an interesting question. It opens up so many avenues about like, what does all mathematics mean? So, you know, what, you know, it really is getting into the question like, what actually do we mean by mathematics? I mean, I think the answer to most ways of phrasing the questions has got to be no, right? You know, Dave's pointed out absolutely correctly, we don't really have generalists in maths anymore. We have like people who are, you know, specialists in group theory like Alex, or you know, in particular areas of applied mathematics or statistics or whatever, probability. But we don't really have generalists anymore. You know, Mandelbrot, kind of the last of the generalists. You know, and that was more than 100 years ago now. But on the other hand, it is interesting to think about what sort of completionism you can do in maths. And, you know, you've got to think that most undergrad courses are giving you a pretty good overview of what's going on. You know, so that's one way of thinking about it. I also wonder whether von Neumann was a generalist. I don't know enough about von Neumann. I know he contributed to a lot of areas for sure.
What's the von? Because what's the von Neumann? Is it the von Neumann probe or something like that? Is that the?
Well, like... he had a contribution to kind of computer science. He had von Neumann probe. I've not even heard of that. A spacecraft capable of replicating itself. Oh, that doesn't sound.
That's the one.
I'm sorry, that just sounds like a Black Mirror episode. I don't think that's a good idea. No, yeah, but yeah, so no, I don't think it's possible to learn it all. And I have to say it's quite interesting. You know, you can.
Hello, James.
Oh, hello. Well, I thought
what are you doing up at this time?
Well, you know, I saw you were taking a long break, so I thought I'll come and shoot the breeze with Adam.
Right. Yeah. Well, we did that set numbers and functions paper, or foundations of pure maths as they call it now. Quite hard actually. It was harder than it usually is. Yeah, some tricky number theory questions that I was just like, um, you know, not really prepared for. But yeah,
Yeah, I mean, you know, I never like it's never my patch. I don't like that nasty modular arithmetic. Give me that nice normal arithmetic any day.
yeah.
Um,
Anything discrete is not really in your wheelhouse, is it?
no, not really. But spoof we did, but it was a team effort, that's for sure. Um, so yeah, yes. So no, I didn't see that. How did the further maths paper go?
I think team effort is being generous because there's someone called Kat in the chat who basically solved the question for me and also gave me a lot of hints for the preceding number theory question. Um, the further maths wasn't unexpectedly terrible. It was as terrible as I expected it to be. Which
Yeah.
was like, it's just a nightmare of algebra. They love asking those really technical questions, where it's just you've really got to be on your guard all the way through. So many little errors that can pop up. So yeah, I've just changed my mind on the exam I'm going to do next. I am going to push ahead with an A-level paper, which is harder because looking at the string of papers and looking at the time, I'm feeling like I've got quite a bit of energy here. So I'm going to get through this one, which I think will be quite tough. And then I've got a string of quite like easier papers, and I'm going to try and like power through the small hours of morning, getting through those to try and catch up with myself. And then we'll see where we are. So this is an A-level paper 2, still pure. The paper 3 is like a split between statistics and mechanics. So let's power through and do this one.
You want to just change the name on your counter thing?
Overlay.
Yeah, I've just done that. So
Oh, okay. Oh, sorry.
Okay.
no, it's all right.
Sorry.
There's a bit of bit of lag there. No, but thanks for reminding me. It's better to remind. Anything
We also
happen?
have another anonymous donation to make it nice and a nice and round number.
You can tell it's a bunch of mathematicians.
Yeah, exactly.
That's great. Yeah, whoever you are, anonymous person, thank you very much for that donation. So a nice square 3,100, which is of course not a square number, but who's counting? Right. let's.
I'm going to make a move, and I'll see you in 4.5 hours.
Are you still okay to make that, James? Because you're not had much sleep here, or have you woken up to?
I had a nap this afternoon.
Okay.
So
Yeah,
I adjusted my sleep schedule somewhat to accommodate this.
Perfect. At least it's not on your birthday this time, which was the preceding 2 years.
Oh well, no better way to spend it. All right. Good luck, and see you later on.
Thanks very much.
Yeah.
I'll see you later.
Bye.
Right, Creamer. Here we go. A-level maths. See how much of this you remember.
Here we go.
You can solve this one for me, can't you? Arithmetic series.
Yeah, that's it. I'll do it.
No, it's fine. So yeah, I do need to kind of go. Well, I've done 10 papers in 11.5 hours. It's quite bad. But the string of papers I've got the IGCSE, I've got 2 GCSEs, and I've got the old spec A-level, which is like the kind of exams that we used to do at A-level, which are significantly shorter and easier. So I'm hoping I can use that to just like blast through, about 8 papers in about 5 hours or so. So it should be okay. Now, an arithmetic series. The first term is 16. The 21st term, which we'll get like that, is 24. And this is a bit funky already. So 20d is equal to 8, therefore d is equal to 0.4 or 4/10. So that's the common difference of the series. Hence, find the first 500, the sum of the first 500 terms of the series. So we want the sum of a plus nd, where n runs from 0 up to 499, I suppose. This is just this is ugly, isn't it? So this is 16. So this is 16 times the sum of 1 as as n runs from 0 to 499 plus 0.4 times the sum of n from 0 to 499. So this is just 16 times 500 because there's 500 terms there, plus 0.4 lots of 499 plus 500 over, sorry, 499 times 500 divided by 2. So let's see what that turns out to be. Oops. 16 lots of 500 plus 0.4 lots of 499 plus 500 over 2. It's that 57,900. I think there is actually a formula that you can apply for this, but I've forgotten it and I can't be able to look it up in the formula book, so I think this is fine. I don't know if you want to check the answers as we go along on here. So we've got a couple of functions. So the range of f, well, f, it's going to be all real numbers y, such that y is less than or equal to 7, because it looks like that. It goes through there at 7. Find GF of 1.8. These are weird questions, I have to say. So f, so f of 1.8 is 7 minus 2 1.8 squared is 13 on 25, and then if we map that over with G, we get 3 times that over 5 times that minus 1, which is 39 over 40. And then find G inverse of x. So the thing we usually do here, let y equal 5x minus 1, and then make y, and then make x the subject. So if we multiply up there, we'll get 5xy subtract y subtract 3x is equal to 0. Pull the x out of there, so we get y over 5y minus 3. And then, of course, G inverse of x is equal to x over 5x minus 3. Usually looks sort of similar to the original one, kind of a mirror image in some way. You know, you got 3, 5, and 1 floating around, 1 negative. It always kind of looks a little bit like that. Okay, well, that's that one. Always start you in with a few easy ones. I definitely really shouldn't say that. 56 squared. Thank you for your donation of 6 squared. That is excellent. Thank you very much for that. And no pennies there either to keep it nice. At least an integer, which is perfect.
The total value now is 56 squared.
Oh.
He's done well there.
Oh, of course. Yeah, very good. Very good. He's been waiting. They've been waiting all night to do that. Yeah, if I donate now, I've got to donate like 400 quid. So I'm going to wait a little bit, see if it gets there. Okay, so a bit of the old logarithms. So if I do 12y plus 5 over 1 minus 3y, 3 to the power of log of that is going to be 3 to the power of, so is that. So 12y plus 5 is equal to 9 minus 27y. So add that over there. We get 39y is equal to 4. Y equals 4 39ths. Just an absolutely disgraceful answer. I don't even trust this. So let's just check it. Log base 3 of 12y plus 5. Subtract log base 3 of 1 minus 3 of that. It is 2. It is right. Do you have the mark scheme for this, by the way?
Oh, sorry, no.
It's all right
Let me look at that.
it's don't worry about it. Okay, so given that theta is small and measured in radians, use these small angle approximations to show that that happens. Right. Well, I think there's two ways of doing this, because a small angle approximation of cos is 1 minus theta squared over 2. That's in the formula book, actually. I'm pretty sure this is right. But then we have to square it. So what I might do actually instead is this is 4 sine theta over 2. Let's convert this into 1 minus sine squared theta, because the small angle approximation of sine is just theta. Well, theta over 2 in that case. Of sine x is just x. So this is 4 theta over 2 plus 3, 1 minus theta squared. I think that's much easier than juggling that and then having to square it. So this is 3 minus 3 theta squared. So in the correct form, 3 plus 2 theta take theta squared. Well, approximately, let's say. Fine, that's fine there. Cos theta equals 1. Well, no, because the function for small values of theta, I'm pretty sure it is 1 minus theta squared over 2. I think that's what we do there. I know for incredibly small theta it is obviously 1, but I think this is how we do it. Okay, some polynomial differentiation now. This is kind of the first thing you do at A level, is you learn how to do this. So dy by dx is equal to 20x cubed subtract 72x squared plus 84x subtract 32, and then d2y by dx squared is equal to 60x squared subtract 144x plus 84. B, that's part 2. Verify that C has a stationary point. Now verify means that you're allowed to just plug in. So if I say 20 minus 72 plus 84 take 32, which equals the value of dy by dx when x is equal to 1, well, we get 104 subtract 104, which is 0, so that's confirmed. And then verify that it's a point of inflection. Well, if we put it in there, we get 60 plus 84 subtract 144, which equals 0, so it is a point of inflection, or point of interest, I guess, because if it was negative it would be a maximum, if it was positive it would be a minimum, if it's 0 then it's a point of inflection. Or I think it could be that it's indeterminate actually, but no, I think it is a point of inflection. So that's all fine. Very easy question really, because usually, because with the new A level they usually try and really drill down and ask you some tricky, you don't really get the standard calculus questions anymore like we used to get. Right, so this looks more interesting. So we've got O, A, B, C, D, E, F, O, my favorite shape. That's the design for a logo. In the design, these are okay, fine, just spelling out what we've got written down here in the diagram.
Sorry, just to interrupt you, a couple more donations.
Oh yeah, no worries.
Someone was desperate to try and get it to pi, but then immediately was beaten by a donation that ruined it.
Right. Yeah, that would have been, yeah, so I can see, yeah, 3, 1, 4, 1, 5, yeah, 9 there. All right, well, thank you very much, Pi, and I applaud the Pi related effort. April, I don't want to say you've ruined it because I am incredibly grateful for the donation. No, just having a laugh. So thank you very much for that, both of you. I really do appreciate it. Thank you very much. So write down in terms of theta the size of angle AOB. Again, what a bizarre question. Because whatever it is, 2 of them plus theta is equal to 180. So it is 180 subtract theta over 2. Again, and why are you throwing marks to an A-level student for that? B, show that the area of the logo, okay, now we're talking, is that, well, the area of, oh god, what is it? Is it half r squared theta? For radians at least. So half r squared 180 minus theta over 2 times 2. That's the area of these two sectors. And then we're going to add the half times the area, half r squared, where r is 2r in this case, theta. So half and 2 go, and then we've got r squared over 2, 180 minus theta, plus, well, this is 4r squared over 2 is 2r squared theta. So another word for half is 2 over, sorry, what am I doing? Another word for 2 is 4 over 2. So if we pull out that half and we pull out the r squared, then we're left with where is that pi coming from? Oh yeah, so yeah, pi in here. Oh yeah, God, that was a massive brain fart. So I just looked at this pi and like, there's no pi, so why the heck not? So then we get pi minus theta plus 4 theta, which is the 3 theta plus pi that we wanted, so that's fine. Okay, now find the perimeter of the logo. Yeah, shouldn't have been mixing my units up there with degrees and radians. Jeez. So I've got, so I need the perimeter of this. Okay, so we've obviously got 2r plus a further 2r, so we've got 4r. And then I want r times that angle, whatever it was. I'll look at what it is in a second. Add 2 of those, which is this and this, plus 2r theta. Right, so 4, well, this is r, 4 plus 2 of that angle, which was pi minus theta over 2, pi minus theta over 2, plus 2 theta. So r, so the 2's go, and I'll have 4 plus pi plus theta. Sure.
I've got the mark scheme now, by the way, and that's correct.
All right, perfect.
all fine.
That's good.
But the only, just a caveat here is that I'm behind on the stream, so I'm watching it on YouTube, obviously hearing you, so it's a bit tricky to actually mark it. But
okay, no worries. Yeah, I'll try and announce what my my final answer is. I think there's the latency seems to have really gone up actually, because it was just a few seconds behind on my first stream. Yeah, we are like significantly behind here actually. Yeah, I'm looking at the stream now. I've not even gone on to question. I'm not even looking at question 7. So we're about, you know, I don't know, almost a minute behind, I'd say.
Yeah, it's really bad.
Getting a question about 6 here, but if you said it's right, then that's fine.
Yeah, 4 plus pi. Yeah, the answer is 4 plus pi plus theta. Is it theta?
Yeah. All times are. Okay, so yeah, I'll try and announce my final answer so you can like at least try and read it, which is not easy. I appreciate, because it might be in a different order or a different form or whatever.
Yeah, it's alright. It's all good. Yeah.
So this looks more like it, because we're going to do some integration here, aren't we? So figure 2 shows so it's a cubic. The point 5 minus 13 lies on C. Use differentiation to find the equation of L. Okay, I'll gladly do that. So dy by dx is 3x squared. Take 20x plus 27, and that equals 0. So let's do, come on, factorize. I've had enough. I've had a lot of bad luck today with the polynomials that don't factorize. 27. How do you make 27? It's got to be 9 and 3, right? Oh, don't tell me it doesn't factorize. This is ridiculous. I think it does. I'm just not seeing it. I'm annoyed at how many bad quadratics have popped out of this. No, it doesn't factorize. So have I done it right? 3x squared. Oh yeah, very good point. Why are we setting it to 0? I don't know. I'll be honest with you. I have no idea. Because I'm so used to it must be a stationary point, so you set it equal to 0. We want the equation of L. Why do we need to use differentiation to find the equation of L? Oh, because if we stick... Yeah, because I think we actually don't need to do that. Because we actually can work out what the gradient is the old-fashioned way. But if we stick 5 into this, then we get the... so this is equal to... Jeez, I'm just like... I don't know. Making a mess. Take 20 of that plus 27. This is equal to 2 at x is equal to 5. So the gradient... so the line L has equation y plus 13 is equal to 2x minus 5, which is y equals 2x, minus 10 minus 13 minus 23, which is exactly what we thought it was going to be, because, like I say, we could have worked this out by just substituting x equals 0 and working out the gradient the old-fashioned way. Yeah, sorry about that. I was in autopilot there, setting it equal to 0. She's thinking, oh yeah, stationary point, whatever, but it's not a stationary point, obviously. Okay, hence verify that L meets C again on the y-axis. Well, it does, because y equals minus 23 at x equals 0, and y equals minus 23 when x equals 0. So this is L, and this is C, which is a silly way of doing it, but, you know, it's obvious. Oh, I suppose that's the point, isn't it? We didn't know that it met L at the y-axis there, so we couldn't have done it the old-fashioned way. But anyway, so C, use algebraic integration to find the exact area of R. So this is what we're talking about. So the strategy here, if we integrate C from 0 to 5, I know this is bad notation, but screw it. That'll give us the area under the curve. It'll give us all of this. Let's call this S. And then we know that if we do the... oh yeah, sorry, S ends there because we're doing it between 5. So this is all S. So all of this stuff here. That's the area under the curve. And then... if we do the trapezium there, so if we do the area of that whole trapezium, subtract that, that'll tell us the value of R. That's the approach that we're going to take. Let's do the trapezium first. So that's 23 we worked out there, didn't we? So the area of the trapezium is 23 plus 13, some of the parallel sides, multiplied by the height, which is 5, all divided by 2. So that is 36, that's 90. So if we do the integral now. So the integral of x cubed, take 10x squared plus 27x, take 23 dx between 0 and 5 is x to the 4 over 4. Subtract 10x cubed over 3 plus 27x squared over 2. Take 23x between 5 and 0, which is Well, all the zeros just they die off in there, so let's just substitute 5 into here, so 5 equals, and then we're going to do that to the fraction that to the 4th over 4, take 10 of that cubed over 3 plus 27 of that squared over 2, subtract 23 of, oh no, 5 equals, and I want to do that. Oh, gross. 555 over 12. Fine. But the actual area of under C, the area S, was what I called it, is actually 455 over 12. So if we do 90 subtract that, that will tell us the area of the region R, and the answer I get, if you want to try and check it, is 625 over 12.
Yep.
Or 52.08. Yeah, is that right?
Yeah, 65 over 12 is right. Yeah.
625 over 12.
Yeah.
Perfect. Excellent. Good stuff. That's what we're talking about. That is. Can you think of a more traditional A-level question than that? That's like what the A-level was all about. Okay, the curve C has this equation. Oh yeah, sure. That's a really good point. I could have just integrated C subtract L. Yeah, I always forget that you can integrate a line. It just it just never feels right to me, because I always think of calculus is the thing you do with curves, but there's no reason why you can't. So yeah, and that would have been the area under the curve. And James McGaw, the old man, thank you very much for joining. So what time is it there? Must be like 6:50 or something. So yeah, this is always the time where you like put your feet up and have a beer while I'm toiling away doing maths papers. So so
I think you also had another donation. I don't think did we address this one?
oh right, so the 40th hexagonal number. I love this. Something really there's a trend been set here, isn't there?
Yeah.
So hexagonal numbers. These are numbers that look like that. So the first one there, and then something that looks like that. 1, 2, 3, 4, 1, 2, 3. So the 40th one of those apparently is 3,160, which I can believe. So excellent work. Thank you, whomever donated that. I really appreciate it. So let's do some more of these. Okay, so this looks like an implicit differentiation question. So if we do 3px squared plus qx y dash plus qy plus 6y y dash is equal to 0. Okay, and then it's just a matter of rearranging. So if we get the minus qy over there, if we get the subtract 3px squared over there, and then we factor out the qx plus 6y, then we get something that looks like that. Which is the form that it wants it in, even though I've written it in a slightly different form, but that's fine, they're all integers, I can cope with that. Given that 1 minus 4 lies on C, the normal to C at P has that equation. Find the value of P and Q. Right. So, xy equals minus 1, minus 4 on the curve itself will tell us that minus P plus 4Q. Oh god, 3. What's 4 squared? 16 times 3 is 48. Plus 48 is equal to 26. So that's one of the equations that will govern P and Q. Tidy that up a little bit. 4Q minus P is equal to 26 subtract 48 minus 22. Just going to double check that, because definitely 4q there, yeah, and then 3 times minus 4 squared is 48. Okay, I'm happy with that. Now, we also know, so the normal to C at P. So if we rearrange this, we get y equals minus 19x subtract 123 over 26 over 26. Could the numbers be any worse? So the gradient of this is minus 19 over 26, which means dy by dx, the gradient of a tangent at that location will be 26 over 19. So dy by dx is equal to that at that point there. So if we substitute in now, so this is equal to, when y is minus 4, that term becomes 4q. When x, so that's 1, so just subtract 3p, over minus 4q, no, just minus q, because x is minus 1, subtract 24. Once again, I'm just appalled by this. I think it looks ugly, but at the same time, there's no way to make 26 over 19 look pretty. Losing confidence in this. So 26 minus q subtract 24 is equal to 4 times 19 is 676. Q minus 3 times 19 is 57. P. This is hideous. Right, well, we'll create a negative 26q over there, so 76 plus 26 over there, that's 102q, that deals with this. 26 times 24, 624, so negative 624. What is going on? I really do despise when the questions are just so ugly. I actually think the easiest way of doing this might be if I just say P is equal to 4Q plus 22, and we'll do it by substitution. So 102Q subtract 57, 4Q plus 22. This is 102Q. 57 times 4 is 228. 57 times 22, take 1254. Okay, so 102 subtract 228 is minus 126. And I'm hoping something magic is going to happen very soon, because boy do I need it. Minus 126q. So negative 624 plus 1254 is that 630, and yes, that is 5 of those. So this is magic. So if I now divide by minus 126, minus 5. Okay, confidence regained. Times that by 4, add 22, and we've got P is equal to 2. So P equals 2, Q equals minus 5.
Correct.
Yes.
That's also really, it's really interesting to look at the Marcus game, because there's just a huge gap between what you just did there.
Yeah, I know, it's amazing, isn't it? It's like, yeah, they get the method mark for setting it up, they get some method mark there, and then that's the answer.
Yeah, exactly.
Just...
Nice.
Yeah, Bracco, you're absolutely right. I should just trust the question, but I don't. So, show that. So we've got an infinite sum here, and I think this is simpler than what it looks like, because 180n, so cos of 180n is equal to 1 when n is even, and -1 when n is odd. So this is just a pretty janky way of saying, do you know what your multiples of 180 are in your trig functions? So again, just squeezing out knowledge from the students. So this is n equals 2 to infinity of 3/4 to the n multiplied by -1 to the n. This is basically just a whole way of saying -1 to the power of n. And where are we going? How are we going to do this? So what I'm thinking is this is going to be equal to the sum of n equals to n even up to infinity of 3/4 to the power of n. So that will be 3/4 squared, 3/4 to the 4th, and so on. And then we will subtract the sum n equals 2 to infinity for n odd. And I know I should probably start that from 3, but I'm specifying n is odd, so it's fine, of 3/4 to the power of n. Now, these are geometric series, and it's a over 1 minus r. That's about the only series formula that I do remember. When n, so this one, right, let me just think a little bit careful here. So the first term of this is going to be 3/4 squared, and the common ratio, because we're skipping, we're going to multiply by 3/4 squared each time. So this is going to be over 1 over 1 minus 3/4 squared. And then we're going to subtract something very similar, 3/4 cubed over 1 minus 3/4 squared. So this is 9 over 16. And another name for 9 over 16 is 36 over 64. Subtract 27 over 64. All divided by 9 over 16. 1 minus 9 over 16 is 7 over 16. And another name for that is 28 over 64. Because this is going to be 28 over 64, lots of 64 over 28. That's why I converted it, so that now that this numerator matches up with that denominator, and that equals 9 over 28. Yes! Oh, that was good. I was very much in control of that. That felt great.
So I was about to say that's correct.
Yeah, yeah. Show that this is 9 over 28. Correct.
That is.
Yeah,
yeah.
You're helping. It's fine.
There is about 5 alternative answers for this, and yeah. Let's just carry on.
Yeah, I mean, again, the A-level mark scheme, it'll often say way 1, way 2, way 3, and then at the end it will just say, or any other correct method.
Yeah, exactly.
So it's like, yeah, good luck whoever's marking that, because if it's not one of those, you've got to check whether it's a valid method. So, and sometimes it could be tried to, because I've marked, I haven't actually officially marked A-level papers, but I've marked mocks and things like that, and if you do it properly, it is actually quite technical, because if they've done something that looks correct and they've managed to get the right answer, how do you know whether it's a valid method? Because you do need to verify that it is a generalizable method rather than just a bodge. You know, they've managed to do it in that case. So, you know.
Yeah, that's interesting.
So yeah, it's a tricky, it's a can of worms, really. So the time t that a pendulum takes to complete one swing is modeled by that formula. We actually know what is a pendulum. Is it 2 pi root L over G, where L is the length of the pendulum? I think that's right. That's simple harmonic motion, A-level physics. So, we should get something that looks like this. Yeah, so the 2 pi over root G is your constant, or 2 pi, yeah, and then your B is going to be turn out to be like a half or something like that. So, something along those lines. So, show that this relationship can be written in that form. Ah, right. So this is interesting. This is basically like show that you can write it in a log-log graph and get a linear. Well, it's not a linear relationship; it's a logarithmic relationship. But like you draw it in log-log because that's the relationship that you're trying to prove. Anyway, so if I take I will say let log equal log base 10 because I can't be writing base 10 everywhere. So log t is equal to log. That's tog. I've just written literally the wrong word. A L to the B, and that is log A plus log L to the power of B. And yes, this is B log L plus log A as required. Now, a student carry out an experiment to find the values of the constants A and B. Student recording the value of t at different values of L. Okay, figure 3 shows the linear relationship between log of L and log. Yep, okay, the strain like blah 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 blah. Find the complete equation for the model. Okay, so we've got a straight line here. Now I can get a little bit confused sometimes with this, so I sometimes like to relabel this as like as a relationship between y and x, because the log t is taking the place of the y, the log L is taking the place of the x. This point here is taking the place of C, so that's going to be our log A there, wherever it goes through the y-axis, and then M, the gradient, is going to be B. So what is the gradient of this line? Well, it's gone up by 0.45, and it's taken 0.28 to do it. So 45 over 28, which doesn't simplify. Nope. So I hope these are rational numbers. So that is 45 over 28. And now when x is equal to 0, i.e. log base 10 of L is equal to 0. Oh. Oh yeah, sorry. Oh, we could just find the, sorry, so y equals 45 over 28x plus c. And then we've got some information here already. So let's do this one. 0 is equal to 45 times minus 0.7 over 28 plus c. So c is going to be equal to the positive of that. So 45 times 0.7 over 28 is 9 over 8. So our whole thing now, but remember, log base 10 of A is equal to 9 over 8, which means A is equal to 10 to the power of 9/8. So 10 to the power of that, which is 13.3. So my answer, Karima, A is 13.3 and B is 1.61.
This is for 10B.
Yeah.
I'm not getting that. I've got, but okay. There's 3 separate answers, but okay, because I'm trying to catch up with the stream.
Oh, I know what I've done. Yes, thank you, Shiru. Yeah, 0.2. Yeah, I read that as 0.07 for some reason. No, it's okay. It's okay.
Okay.
Oh, in which case, I've kind of goofed up this whole thing really. So we're gonna have to do this again really. So it goes up by 0.45 and it goes across by 0.91. I should have really noticed that because at the start of this whole question, I said that B is going to be approximately equal to a half, which this is very much approximately 1/2. So B is in fact, you can check this one, 0.495. Pretty confident about that now. And then we've got y equals 0.495 x plus c, and then again 0 equals, so that times 0.7 will be the so c is equal to 0.346, but again that is log base 10 of a is equal to that. So if we push them up to, so a will be 10 to the power of that. Oh, shoot. To the power of 0.346. 2.22. So a is 2.22, b is 1.61.
Okay, I think you still got B
sorry,
wrong.
no, yeah, it's not 1.61. It's what was it? 0.495.
Yes, correct. Yeah.
All right, thank God. Right. Yeah, because like I said, the pendulum equation is it is a root. We are rooting L. That is actually, that I'm sure. I might be wrong on this, but I'm pretty sure that this is the actual pendulum equation. So we are expecting L to the power of a half somewhere in here. So this is about right because this is experimental data, which means it's not going to be theoretically, perfect.
Yeah.
So I'm fine with that. Just want to read that comment actually. Oh, thanks so much for reaching out there, saying that you followed me from my first video, which is absolutely lovely to hear. Thanks for. It means a lot actually that someone watches one video and then subscribes and then thinks I'm going to watch all of this guy's videos because I'll be honest, I don't think I would do that. You watch a lot of YouTube, don't you? Like, would you ever watch like one video? It's quite hard to earn a subscription for me, which is a little bit. I don't know, it's a bit hypocritical because I want people to subscribe to me, but but it really does mean a lot that people did like watch that first one because I got to 10k subs like very, very quickly, and that was just pure. I thought that would be the hardest part of the whole thing is how do you get off the ground, but I just had that really, really lucky first video with the Summer of Maths Exposition, of course, which really helped, I think, bring a lot of traffic to it, and I think I just got so lucky getting off the ground, and then from there, at least you've got some following to try and work with. So thanks so much for saying that.
Yeah, but the different, there's a bit of luck, but also your first video was very polished. Like it did look like someone who's been doing it for a while. Like I think there was an element of skill to it as well.
Well, yeah, but you do need luck. There's no two ways about it.
Absolutely.
Yeah. So yeah, it's yeah. I mean, I've been planning that video for like 10 years, and then I looked back at it a few weeks ago actually, because it's taken off a little bit again. It was hanging around 140k, and now it's like it's gone up beyond 200k. It does that. Wow. Like it ebbs and flows. All of a sudden the video will pick up again, and it seems to be it's quite a chaotic process. But so I was looking at it again, and I was just cringing. Like I think that video isn't very good now, but it still resonates with people. But like I watch it now and think, God, get on with it. It's like very, very slow, and it was just like I don't know, just very. I don't know, sluggish. And I'm like, if I made that video again now, I would make it very differently. But that's the way, if you don't look back, someone said it once, if you don't look back and think what you did a year ago was rubbish, then you haven't really improved. you know.
Yeah, exactly. Yeah,
So
yeah, yeah.
so
You shouldn't be happy. You shouldn't be happy with what you did, what you produced a year ago.
you shouldn't be happy because it was rubbish.
You should be only disappointed in life.
Yeah, that's it. That's it. You've pretty much sum up my entire character. Yeah, no wonder I've got all the mental health issues. Like, yeah, I'm only ever disappointed in anything that I've ever done, which is a little bit too close to the bone now. Actually, let's stop there because it's getting a little bit too real. So, right. With reference to the model, interpret the value of the constant a. So, um, well, it's when this is 0. So when log so L is equal to 1. So I think it is a length 1 pendulum will produce log base 10 of t equals log base 10 of a, so t equals a. So it is the period of a 1 meter pendulum. I think that's right. Is that anything close to what it's saying in the mark scheme?
Sorry, I got very distracted by our chat. Which one are you on now?
So the 10c, it's interpret the value of the constant a, and I'm saying it's the period of a 1 meter pendulum.
Yeah, correct.
All right, perfect.
Sorry.
That's fine. I just realised because I was just wondering why the hell do I know that the formula for the equation of a pendulum? And I just remembered that Taskmaster video. So for those watching, like our big group of friends, we do like all these kind of silly, kind of games that we play and stuff like that. And we did like a Taskmaster where everybody had to make a video of their. If you've never watched Taskmaster, it's like you get a challenge to do and you have to try and complete it in a funny or interesting way. And then the challenge was to do the most preposterous thing with a chickpea that you can think of. So I calculated the mass of the Earth using a pendulum made with a chickpea, which I thought was pretty preposterous.
Yeah, that's great.
What did you do for that one?
I made
or is it not
motion animation.
Oh yeah, oh that was a really good one. I mean, yours are always very good because I think you're, I don't want to, blow smoke up your backside. Very funny. You always get good ideas with that sort of thing. It's like it's coming up with a good idea, isn't it? If you get a good idea, it's like you think, yeah, this is going to be great. But if you don't, God, it can be really difficult to just know what to do. I always find if I don't come up with an idea within 2 minutes, that's it. I'm not going to think of anything. Right, so we've got a graph, like an absolute value sort of graph there. So it shows a sketch of the graph with that equation. Sketch the graph with equation that. So we need to do that, which is going to have the effect of reflecting in the x-axis, and then we need to bump it up by k. So I think it's going to look something like well, let's just be a little bit precise about this. So when 2x minus 3k equals 0, then x is equal to 3 over 2k. So this here is 3 over 2k 0. So it'll be about twice as tall, yes, that distance, and then again. So I think where I put that dot actually is not bad. Let's draw this in then. I'm just, where does it go to the y-axis? So it's going to go through the y-axis at k plus 3k at 4k. What? Minus 2k. So it does go through the y-axis on the negative side. So I think it's going to look something like this. So that is f of x. Find in terms of k the set of values for which that is greater than x minus k. Right, I'll tell you what, instead of trying to squeeze it on that little rubbish bit of paper there, let's start a new one. So we could do this geometrically, but I don't think I'm going to. So if we add it to both sides, yeah.
I've got to dip out for 5 minutes. Okay, sorry, I'll be back in a minute.
Yeah, no worries, no worries. So, minus 2x minus 3k is greater than x minus 2k, and then 2x minus 3k is less than x 2k minus x. So it could be the case that 2x minus 3k is less than 2k minus x. And in that case, we get that x is less than 5/3 of k. Or it could be the case that 3k minus 2x is less than 2k minus x, in which case we get that x is greater than k. So the set of values is that k is less than x is less than 5/3 of k. Now it wants this in set notation, so I guess x is in the interval from k to 5/3 of k. Or what else? How else could we say this? This is the set of real numbers k for which the set of real numbers r for which k is less than x is less than 5/3 of k. Something along those lines. I mean, they're all considered sets. That's fine. Find in terms of k the coordinates of the minimum point of the graph with equation that. Right. So y is equal to 3 minus 5. Now f of a half of x, so f of x on 2 is equal to, well, let's just write here, k minus absolute value of x minus 3k. So the absolute lowest that could be, if we want the minimum, is when that is 0, right? So x is equal to 3k will yield the minimum, because this is always non-negative. So the absolute smallest it can be is 0. So I think 3k, 3 minus 5k, they will be the coordinates of the minimum. Creamer's just out for a second. But I'm fairly sure that that's right. If we, when he comes back, I'll verify that answer with him. All right, we're getting through this, actually. Oh dear, this looks complicated. And again, we've changed font. So maybe it's the PDF that I found or something like that, because it's not really rendered properly, this PDF. We've had this problem with a few of them where it just stands out like a sore thumb, some of these variables, if they're not italicized. Right, so use the substitution that. So u is equal to 1 plus x to the power half, which means du is equal to a half x to the minus a half dx, which means 2 du. So dx is equal to 2 du over root x, which is equal to 2 du over u minus 1. So seems like a good start. Although maybe I think I'm going to use this form actually. So let's substitute it in. So this is the integral of, I'm going to leave that as x over u times 2 du over root x. And I'll worry about the limits in a second. This is 2 times the integral of root x over u du, which is equal to 2 times the integral. Now root x is this doesn't look anything like what's written there. Cubed. That is a minus a half. And that's where the cube's going to come in. So, in fact, that is root x up there, isn't it? So, this is actually that. So, yeah, this is the integral of 2x root x over u du. And now x root x is x to the half cubed, which means this is where the cube comes in, because x to the power half is u minus 1. Okay, we're looking in better shape here. So 2 u minus 1 cubed over u du, integral of. The only thing we need to do now is change the limits. So this, when x is 1, we get u is 1, and when x is 16, we get 5. So there we go. B, I assume we just have to evaluate the integral now. Hence show that that is that. Yes, fine. So, oof. We're going to have to expand that out, aren't we? Yeah, we're going to have to expand that out. So this is equal to the integral from 1. Right, well, no, let's pull the 2 out. And u subtract 1 squared, well, cubed even, that's u cubed subtract u squared, no, 3u squared plus 3u plus 1 all divided by u from 1 to 5 du. And now we can tidy this all up actually. So this is, okay, I thought this was going to be a bit of a nightmare, but I think it's going to be okay. U squared, take 3u plus 3 plus 1 over u du, which is 2, lots of, u cubed on 3, take 3u squared on 2, plus 3u, plus log u, between 5 and 1. So, into the calculator, if I do that cubed over 3, no, over 3, thank you, subtract 3 of that squared over 2, plus 3 of that, so I get 2 of 115 subtract 6 plus log 5, subtract, and then when this is 1, I get a third, subtract 3 over 2, plus 3, 11 over 6, plus log 1, and that's 0. So, all in all, 115 subtract 11 divided by 6, 52 over 3. So 2 of 52 over 3 log 5. Now this should be negative. It's this. Subtract 1. Subtract. 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 Okay, no harm done. 104 over 3 subtract 2 log 5. Right, well, let's take my calculator out for a spin here, because my calculator can actually do this. So let's do the integral x over 1 plus root x between 0 and 16. I think it just uses some numerical methods. But it usually comes out pretty good. It's really thinking about it. Come on. You can do this. I believe in you. Okay, 31 point. I was worried for a second it actually crashed my calculator. So 104 over 3 subtract 2. Yeah, this looks good. Yes, so I'm very, very confident in this answer now. Since Creamer is away, you can't actually check it, but I'm pretty sure that's right. Okay, the curve C has parametric equations. Now this is the kind of parametric equations questions that I generally quite like, although this is a bit scary, isn't it? Cosec. God, I hate those reciprocal trigonometric functions. Just noticed we've got a donation from Neville. Thank you very much, Neville. Really, really appreciate the donation there. That's absolutely fantastic. £24. And an anonymous donation again. So thank you very much for that. All very much appreciated. And I've just seen your comments in the chat as well. -1. Thank you, guys. I should check that chat a little bit more often, but I try. The thing, I'm not looking at it because I do really want to try and solve the questions on my own first, because I genuinely just like enjoy answering the questions. So I think next time I'm struggling, I will look up. I am trying to respond to your comments, questions, and anything like that as well. Right. So that cosec, it looks a bit scary, but I think we'll do cosec theta all cubed. That's how I like to think about it. So this is 3 cosec squared theta. That sounds like you're back there, Creamer.
Yeah, back. Hello.
Well, it was a while ago now. I wanted an answer check, but
Oh dear.
Can I have a 11C, please?
Yeah, sure.
And a vowel.
Yeah.
Is it 3k 3 minus 5k?
Yeah.
Awesome. The next question was actually my calculator verified the answer to that one. So
Okay, fine.
how do you feel that your work could be done by a calculator?
That's fine with me.
So
Emma sent a love, by the way. She's just got back. That's where I went.
oh right, okay, brilliant. Right, okay. So yeah, thanks. Thank you for the donation as well. I really did appreciate that.
Yeah, I will do.
So
have you kept up with the donations as well? Because you've got.
Yeah, just before you got back, actually, I did. I'm just cheating here, basically. I'm just looking at what the derivative of cosec is, and the formula book tells me it's cosec theta cot theta, which, don't you just hate them? So this is 3. So that's not equals. Sorry, this is y dash is equal to this. So this is. I'll just write it again properly here. So this is minus 3 cosec cubed theta cot theta. One of my patrons pointed out, I thought I'd watched all of 3 Blue 1 Brown's videos, because I really love that channel, and Just a shout out to one of these smaller channels that's out there. The one that I'd never seen, which is his mate got a tattoo of the cosec, the geometric interpretation of cosec on his chest. And then he went through the rest of the video saying why it's such a pointless thing and that we shouldn't really use it anymore. It comes from the fact that there are times when you want to use 1 over sine theta. Obviously, these days we would just use sine theta. We've got calculators that can do it for us. But they would have all of these values in big tables. So you'd have the table of all the sines, all the coses, all the tans, and then all of the co-functions as well. And it was just much quicker to look those numbers up in a table. But we still do it. And there's not really a good reason for it.
Yeah, I was thinking that. I was gonna bring that up if it's actually still a thing. But,
I
yeah,
mean,
okay.
beyond A level, I've never really used them
Yeah.
because you don't need to. Sine, cos, and tan are entirely sufficient, which is what every woman has ever said about me, actually. But, entirely sufficient. So dy by dx is equal to dy by d theta over dx by d theta. So we've got 3 cosec minus 3 cosec cubed cot theta over cos 2 theta. Does that look anything like we've got in the answer book? Minus 3 cosec cubed theta cot theta over cos 2 theta.
Over 2 cos 2 theta.
Yeah, that's right. Actually, yeah. No, that was my bad. I forgot to put that 2 there.
You can see it in your previous thing. Yeah.
Yeah. It should be there. I just forgot to write it. But it's good that you pointed it out. Otherwise, I would have used that incorrect one for the next part, which I think is to find the exact value of the gradient of the tangent C at the point where y equals 8. So why is this interesting? Because surely we just put, where y is 8, not when theta equals 8. So if y is 8, then that means that, so that is equal to cosec cubed theta, and that means that sine theta is equal to 2. Yeah, I thought about simplifying a bit, but yeah, I can't really be bothered because it's not. Yeah, it's not pretty. But I think if we do this, no, sine theta is a half. Sorry, because we need to. So arc sine of half in radians. I don't know why I'm doing this because I know that it's pi by 6. So theta is equal to pi by 6, and then surely we just stick it in there. So this is minus 3 over sine cubed theta cot. Almost lost that 2 again. Cos 2 theta tan theta. Such a strange thing. So this is negative 3 over 2 sine of that cubed. Cos of 2 of them, tan of 1 of them. Minus 24 root 3.
Yep.
Brilliant. Very, very strange 3 marks to throw away at the end there. Right, so we're getting there. Right, okay, this looks interesting. So, I know exactly what this is going to be. I'm going to not look at the paper. I'm going to tell you what this question is going to be. Volume of a tank. It'll be filling up over time, and then it'll be maybe it'll be filling up and it'll be draining or something like that, and then it'll be like find if you leave the tap running all night, at what point does it get to, or something like that. That's what I think it's going to be. So. Water flows at a constant rate into a large tank. The tank is a cuboid with all sides of negligible thickness. Blah, 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 blah. There is a tap at point T at the bottom of the tank. So this is where it's going to spill out. At time T minutes after the tap has been opened, the depth is at H. The water is flowing in at a constant rate of 0.48. Okay. Water is modeled as leaving the tap at a rate of that. Right, so the higher it gets, the faster it flows out, which I suppose is maybe realistic. Show that according to the model, we get that. Right, okay, so it's not trivial actually, because I thought this was going to be about volume. So I was wrong about this, because I thought we were going to do something with the volume, but actually it's all about the height here. So V is equal to 24h, and in 1 minute we get 0.48 of volume. So that means the height increases by 0.2. So in 1 minute the height goes up. So the height goes up by 0.2, and it goes down Once again, I've insulted the question, and now the question is having its payback. Because okay, this is actually not quite as straightforward, because I think we could do the change in volume over time, because this is the natural way, I think, of doing this. Now, what happens to the volume in 1 minute? It goes up by that, and then it goes down by 0.1 h. Now, if we knew dH by dV, and then we multiplied them, we would get dH by dt. That's what I'm thinking here. I don't know if this is the right way of doing it, actually, because this doesn't seem... I think I might be doing it in a non-standard sort of way here. But we need dH by dV. So the change in height per unit volume. But we know that V is equal to 24h. And that means that we know that 1 is equal to 24 dH by dV, which means that dH by dV is 1 over 24. And now we have that dH by dt is equal to 0.48 subtract 0.1h, all divided by 24. And unfortunately, that looks absolutely nothing like what we've got here. Or maybe it does, because now if I times 24 by 50, I get that. And let's push it up there. Oh, this will be amazing if it works, because I did lose confidence here. Now 0.48 times 50 is 24. Yes. And then subtract 5h as required. Yes. Whew. Yeah, I didn't expect that to work. I would be interested. I'm not going to make you go through it, but I'm interested to see what the mark scheme is on that. Does it have anything resembling what I've done here?
Yeah, it does.
Oh, does it? Yeah. All right. Oh, that's a shame, actually. I thought I'd discovered an interesting way of doing it.
Well, I think again, never satisfied. You did it one of the ways. I don't understand what this marks B1, M1, A1 thing means.
Oh, right, but... okay. I'll give you the brief synopsis of a mark scheme. So M1 is a method mark.
Okay.
So a mark awarded for knowing what you're doing. B1 is an answer that you can just state with no working out. So as long as that's written down, you get the mark. A1 is A is for accuracy. So you get an A mark for getting the right answer, but as only if it follows from correct working.
Okay, got you. Okay, yeah, because you're okay. That makes sense. So what you did was written exactly in the M1 marks.
Right. Okay. Perfect. Yeah. So that's the method, and then yeah, because there's a misconception. A lot of students say, oh well, if I write the answer without my method, I'll still get some marks. Actually, no. Sometimes if you write down the answer with no method, they award you nothing because you only get the A markers if it follows from a valid solution. Because like, and then I say to them, well, how do they know that you've not guessed or cheated or whatever? You know, you have to actually know what you're doing. And maths, it's not about getting the answer, it's about the process and all of that rubbish that I tell students, you know. So yeah, so right, I suppose we've got to solve this differential equation now. So yeah, this is a bit of a fussy one, isn't it? If we do dh over 24 minus 5h is equal to dt over 1200 integral of. So this is, I want minus 5 up there because I'm going to log the bottom, but I can't just create minus 5 out of nothing. I've got to times by a fifth. dh is equal to 1/1200th of the integral of dt. So minus 1/5 log 24 minus 5h is equal to 1/1200 t, and we do get the constant flying out there. However, I think we can kind of liquidize that constant later when we come to put it in there. Yeah, liquidize. That's how I'm saying that. So let's multiply this by 5. So 5 divided by 1200, and so this is log 24 minus 5h is equal to minus 1/240t plus, so this is a constant, which means we don't really need to worry about it getting multiplied by 5 or anything like that. So now let's e-ify the whole thing. So 24 subtract 5h is equal to a e to the power of minus t over 240. Bit of an awkward constant to have up there, but that's how these differential equations go. And then we want to make h the subject. So h is equal to bit of the old rearrange. So a e to the minus 10 over 240, which is negative, but who cares? I do need to get the sign of this one right. Plus 24 over 5. Is that right? Yeah, because I'm subtracting it and then I'm dividing by minus 5. Okay, and then the initial conditions. What are they? When the tap was opened, the depth was 2. So just write that down here. So th is equal to 0, 2. So at 2, we get a plus 24 over 5. 2, yeah, I thought a would turn out to be negative, so this is fine. 24 over 5, minus 14 over 5. So h is equal to minus 14 over 5, this is the final answer, e to the minus t over 240, plus 24 over 5.
Correct.
Awesome. All right, and then determine according to the model whether the tank will ever become full. Right, okay, well that was kind of what I predicted at the start, because it's always like, well, what happens at the extremes? Well, as t tends to infinity, so if it just flies off without bound, then obviously this whole thing becomes 0, and h is equal to 24 over 5. Sorry, 24 over 5, which is 4.8. I don't know why I'm doing it on the calculator. 4.8. And the actual tank has height 5. So, no, it will never actually fill up. Yeah, so basically the water only ever goes in at a fixed rate, but as it so it's only ever going in like this, but as the water fills up, the amount that it goes out again will eventually match, and then you know, no matter how long you leave the tap running, it will stay at that kind of equilibrium position at 4.8 meters. That's kind of the interpretation that's there. Okay, we're getting towards the end of this paper now. Must be just one or two more questions, although that feels like a big chunk of paper there, actually. Oh my god, what is that? Yeah, so final question of the paper. Right, so we've got some kind of water wheel here. What on earth is this? God, it's a whole essay as well. Express 2 cos theta minus sine theta. Well, let's not even look at that water wheel. Let's just get our heads around this. So, God, yeah, it just looks like an absolute nightmare, that question. So 2 cos theta, subtract sine theta. Well, r cos theta plus alpha, that is r, oh god, which way around is it? Cos theta cos alpha minus r sine theta sine alpha. Therefore, r cos alpha is equal to 2, and then r sine alpha is equal to 1, and therefore tan alpha is equal to 1/2. So arctan of half, which is that. So 3 sig figs. So alpha is 0.464. And then if we do 2 divided by the cosine of that, well, this actually should turn out to be root 5, I believe. Because I know that actually the shortcut to find r is to do the coefficients, the sum of the squares of the coefficients there. So 2.23, yeah. So r is root 5. So this is root 5 cos theta plus 0.464. That's my answer to the part A.
Yeah, that's great.
Perfect. Yeah, sorry, I did want to check that one, because if that was wrong, then the rest of the question is kind of a bit spurious.
Yeah, that's fair.
Right, let's get our heads around this. So, figure 6 shows a cross section of a water wheel. The wheel is free to rotate about that fixed axis. Yeah. The point P is at the end of one of the paddles of the wheel. How do they come up with these questions? The water level is assumed to be horizontal and of constant height. I'm just going to circle that, because I bet you any money there's like a question which is, oh, well, criticize the model. The vertical height, h meters of P is modeled by, okay, so h, I see, is modeled by that equation, where t is the time in seconds after the wheel starts rotating. Use the model to find the maximum height of P above the water level. God, could they make it any more convoluted? Well, obviously we can use this here. So h is equal to 3 plus. So we want to, what I'm trying to do here is I want to get it in the form 2 cos theta minus sine theta, because then I can invoke what we used here. So if I say this is 2 of 2 cos 0.5t minus sine 0.5t, then we can invoke the first result, because this is now of the form where theta is equal to 0.5t. So this is now 3 plus 2 root 5 cos 0.5t plus alpha, which we found to be 0.464. So that is h, but tidied up a little bit. Now, what's the actual question? The maximum height of P above the water level. Well, the biggest that this, so this is the advantage of what we just did there. Now we've only got one trigonometric function, and no matter what you do with t, whatever value you put in, the largest that could possibly be is 1. So the height max is just going to be 3 plus 2 root 5. Now, the value of t when this maximum height first occurs, so in other words, we want cos 0.5t plus 0.464 to equal 1. And the first time that happens is when this is 0. Don't like that, because then t will be negative. So I guess that's not the first time that it happens. So when is, because cos of, yeah, okay, so the first time it happens, yeah, because cos obviously it's going up and down like this. We get cos of something is 1 there, and then it happens again at 2 pi. So 0.5t plus 0.464 is equal to 2 pi. So 2 pi, subtract the 0.464, and then double it. We get time 11.6 seconds. That's for 15b part 2. Creamer.
Hello. Getting distracted by the chat again.
Yeah, it's alright. No, it's alright, don't worry. So 11.6?
Yes, correct.
Alright, awesome. Perfect.
Sorry. Yeah.
No, don't worry about it. I'm glad someone's keeping an eye on what's going on in there. Anything interesting?
Oh no, we're just having
bants.
So, someone's planning. JG's planning to watch the whole thing.
Wow. I thought the only
I
thought the only person watching the whole thing would be me.
Yeah.
And
oh yeah, we've got one more. We've got just a donation. Remember to stay hydrated. £5.
yeah, it is a really good reminder actually, because you know what I'm like. If I get fixated on something, I will do it at the expense of everything else. So including my own health, frequently my own health actually, physically and mentally. So yeah, it's good. I got a Fanta Zero going here, but I'm really trying to avoid caffeine, because the brief bit of research that I did about doing these sorts of challenges is they do recommend avoiding that, because, like, you know, after the high of caffeine, you do have the big crash. So I had a cup of coffee when I first got up, and then if I need it, I'll have one later when it's like, 7 a.m. or something.
Yeah, that's fine.
Well, it's all very fascinating, but shall we carry on? So we've got now a single revolution of the wheel.
Oh, hang on. Sorry, go quick pause for a second there.
Sorry.
The tuition rooms. Michelle,
that's
£50.
Oh, awesome. Oh, thanks very much, Michelle. What on earth are you doing up at this time? Yeah, so Michelle is my colleague. We run like a little tutoring business together. Well, she runs it. I just teach. So she's a biology and chemistry tutor. So we tutor all the way up to A level. So if you are interested and you're in the Greater Manchester area, we have an office in Altrincham, or we can come around to your house. We do tuition. I teach maths and physics. I teach GCSE physics, and I teach basically every level of maths you can possibly imagine. GCSE physics. I'm not confident really enough to do A-level physics just yet. But yeah, thank you so much for the donation, Michelle. And I hope to see you very soon. Right, so final little bit of this paper here then. So we've got a single revolution of the wheel So it's going all the way around. P is below the water level for a total of 6 seconds. No, that's not 6 seconds, that's T seconds. I just completely hallucinated the number 6 there. So we want... yeah. Oh, that's a good question, actually. So H, we said, was equal to 3 plus 2 root 5 cos 0.5 t plus 0.464. So I know what to do here. So basically, h, there'll be some value of t when h equals 0, and then shortly after, h will be 0 again. So we want to find the first and second time for which h is 0. So if we do it, we get 0. Well, let's just rearrange. So 0, minus 3 over 2 root 5 is equal to all of that. So inverse cos of all of that. And then, well, let's just carry on rearranging it. Let's just go crazy here. And then times the whole thing by 2. No, actually, forget all of that. I just did way too many. I got too excited there because we do need to be careful. So that minus is equal to 0.5t plus 0.464. Let's just calm down. So inverse cos of that minus 3 over 2 root 5. So we get 2.3. Now, on the old cos graph again, looks something like that, and at negative something or other. So that there is half pi, and then we've got the distance between the distance between pi by 2 and that is like 0.735. So if we take 3/2 of pi and subtract that, it'll give us the other solution. So 3 pi by 2, subtract that, and we get that. So 3.977. I definitely should have done that to more dp, so let me just do that again. Inverse cos of minus 3 over 2 root 5. So it's 2.306. And then we subtract 0.464 from these. So if we do that, subtract 0.464, and then times it by 2, so we get 3.68. Seems very low, actually. Seems very low, because it takes 11 seconds to go all the way around. Suppose we don't know when it start, what position it start. Yeah, let's just go with it. So 3.977 subtract 0. I don't like this. I don't like this. It's that, and then we times that by 2. We get 7.026 seconds. Okay, so I think the answer, Creamer, is going to be this. 3.346.
3.34 is the answer.
Yeah, that's close enough. Yeah, I might have introduced a rounding error there because I did 2dp and 3dp there, which is bad practice actually. So that's probably just what I've done.
You've just had a donation from Johnny B for £20.
No, that's not really him. I saw him in the chat asking what the link was, and I was absolutely 100% convinced he's going to put something very silly up there, and that is not the Johnny that I know. No way he's just written Johnny B. I don't believe that for 1 second. But thank you very much, Johnny. I genuinely really do appreciate silly comments aside. I shouldn't really give you ideas, really, should I? So. Explain how the equation of the model should be refined. Oh, in reality, the water level may not be of constant height. Explain how the equation of the model should be refined to take... Well, I don't know. How would you compensate for that? Introduce a height function. I don't know. That's
So the mark scheme doesn't really help with this.
yeah, because it's like, well, how the model should be refined. Well, you can't really model it like that, can you? Because it's obviously if it's wobbling around and everything, then you need some kind of function for which you're basically going to subtract the wobble of the water. What does it say in the mark scheme there, just out of interest?
E.g., the 3 would need to vary.
Right, okay, so that's basically what I just said. Because, yeah, instead of just having 3, you would have, some function of time. So you would vary it over time. So that's what I meant by a kind of height function. I'm going to claim that that's what I meant. That makes the whole thing a lot easier. Sure, let's go with that. Okay, so that is okay. So not doing well. We're not doing great actually because we've done 11 papers and it's taken 13 hours. But I really do need to hammer through some of these.
I think late at night as well. I mean, you might be able to just kind of get your head down and just,
That's what I'm going to have to do.
Yeah. Because I think I'm going to probably go out now with a good time.
Yeah, that's totally reasonable. So yeah, what I'm going to do, just apologies to everybody in the chat here, but I think I do need to. This is usually what I end up doing is just like for a few hours, just absolutely try and smash through a few of these, just to kind of catch myself up. I've got the IGCSE paper here, so these ones should maybe take 40 minutes or so. A couple of GCSE papers should take like half an hour. Thank you, Johnny. Thank you for that. Brilliant stuff. Didn't expect anything. To be fair, I should have seen that coming because I made a hash of that explanation with all of my wobbling water, so 100% deserved. And thank you, I do appreciate it.
It's the late night section now. It's getting blue.
That's it. It's getting more and more nonsensical.
All right. Well, best of luck, Magoo. I mean, great effort up to this point.
Yeah, no worries. Thanks very much for all your help. I really do appreciate that you do this every year. Yeah, I really appreciate it.
Yeah, all good. Pleasure. All right. See you later, everyone.
See you later.
Okay. Bye.
Right. So, let me just update the exam counter there. So, exam 12. And this is IGCSE paper 1. Right, so this is be a little bit of a reprieve from all of the horrible A-level kind of stuff that we've been looking at. I mean, I say horrible. I actually really enjoy those questions. This is calculator, but I think, yeah, I just need to kind of push ahead. I might just actually put a bit of music on in the background here. You shouldn't be able to hear it. If anyone can hear music, please let me know, because I don't want a copyright problem or anything like that. What should I listen to? Something like that. I feel like that music is going to come through there, because it was like right, okay, need to power through some of these because this will be the halfway point and I'm way over half of my time. Feel free to keep chatting, but I apologize if I miss anyone's messages. Right, so the gradient. All right, yeah, thanks for confirming that. That's good. Right, so high jump world record. Simplify, so 9 b cubed over a. Yeah, no worries, Johnny. Thanks very much for the donation. I'm sure you will be back for more silliness. I would expect nothing else. No, cheers, man. Really appreciate it. And thank you to that anonymous donor. Really do appreciate. Keep them coming. Sorry, I am going to be a little bit quiet over this, just because I do need to push through and get a few of these done. So, 2 lots of 3x plus 1. So 1.8981 times 10 to the 27, 5.9722 times 10 to the 24. Who doesn't love Jupiter? In standard form, that is 3.18 times 10 to the power of 2. That seems a bit ugly. I guess that's it. That's funny, actually. I write my Z's the line through it, and then Z, my 7 with the line through, so my brain just auto-corrected my 7 into a Z there. That was funny. So times by 4, times by dad. That's my dad actually. Oh, mistake on that last one, was it? I thought it was. I thought it looked ugly. Oh, I've lost it now. Oh yeah, 12. I can't keep doing this. I do appreciate you pointing out the mistakes, but also I really need to be strict with myself and not constantly go and backtrack and be perfect at everything. So I think it's this. So x to z is 15 to 28, and that I think is as simple as we can make it because that's 3 times 5. That's 4 times 7. Right. So this here. A and B are not parallel, given that all of this where M&M scales funny. No, I don't intend to sleep. Because if I went to sleep, I would never wake up again. Well, that sounds like I'm gonna die. I'm not gonna die. But yeah, I know what I'm like. I would I'd find it very very difficult to get out of bed and face doing the rest of it. So I just need to power through. Plus, I also don't think I've got the time. So 3m is equal to well, no, sorry, m is a third. Yep, and then n is 2/3. Okay, the largest integer n such that so 2x plus 1 is greater than 6x minus 10. Therefore, 4x less than 11. So x must be less than 11 on 4, which means the largest integer is 3, I think, because 11 divided by 4. Oh no, 2. I'm really going to just double check that. Yeah, 2.2575. So given that, find x in terms of y. Well, x squared plus 9 equals x squared. Are they in order? Yes. So the mean is there. So median is there, 7.2. Calculate the mean. Oh god, are you joking? What's wrong with this? Oh, 2. God, I'm being very sloppy, sorry, because I'm trying to do it quickly. Should slow down just a little bit, but I'm really anxious about the actual amount of time that I've got left. So y equals minus x, something like that. And then line with equation y equals x plus 2, so something that looks like that. That one's a bit janky. Slipped down a little bit there as I was drawing it. ABCD is a pentagon. The pentagon is a line. Equation y equals minus x as its axis of symmetry. Okay. 3, 0. D minus 4, 4. Oh no, sorry, y equals minus x is the axis of symmetry. So I was using this line. Sorry. So if we go to there, yeah, I was tipped off to that because the letters didn't go around in order. So A, B, and then 1, 2, 1, 2, C. So actually, yeah, B is. Yeah, that's more like it, isn't it? And then, does it look like a symmetrical pentagon? Yeah, that's nice. Good question, actually. I like that. So y is inversely proportional to the cube of x. Okay, so x cubed y is equal to some constant of proportionality. A half cubed is an eighth times 256. What's 256 divided? It must be a power of 2. 32? Yeah. Yeah. Okay, so we want x, which is the cube root of 32 over 4 over 27. Six. Okay, the nth term. So the first four terms of that, well, this is just powers of 2. So 2, 4, 8, 16. Find the value of that. Giving your answers. So 2 to the power of 500 over 2 to the power of 488 equals 2 to the power of 12, which is 2 cubed to the 4th, which is 8 to the power of 4. Which I think is 4096 actually, but don't really need to know that. Particle P is moving along a straight line at time t seconds. The displacement s of P from a fixed point O of the line is given by that. Okay, so V is 5t squared minus 9t subtract 2. because it's just ds by dt. Find the value of p, so if it's at rest 0. So we reject minus 1/5 because it's negative, can't have negative time. So quadrilateral A is formed by quadrilateral B by an anti-clockwise rotation by the origin followed by a translation. Write down the angle of the rotation. We're going anti-clockwise. So I think we need to take it 270 degrees. Write down the 2 by 2 matrix which represents this rotation. Oh my god. Now what is it? I wonder if someone in the comments can correct me on this. Cos theta minus sine theta, cos theta? It's been a long time since I've looked at that. I think this is it. So cos 270, and we're in degrees again, is 0. And then sine 270, it's like minus 1, isn't it? Wait. Oh, A onto B. Sorry, yeah. So 90. I tell you why I did that, because there was a question that came up earlier, which did confuse me, and I didn't correct properly there. Well, does it make sense? That's minus 1 there. I think this does. I would have expected minus 1 there. Because if I take an x coordinate like 2, 1, then the coordinate that comes out is minus 1, 2. This isn't right. I genuinely can't remember what the matrix is of a. But don't forget, we're not actually pushing it. Yeah, so does it make sense that we've gone from 2, 1, rotate it 90 degrees, should be finished on 1 minus 2. So I think it's that, actually. I think the minus sign might be in the bottom. Yeah, thanks for that. Yeah, I think it is this, isn't it? Because the x values become the minus of the y's. The y's just become the x's. Yeah, but I thought I already took that into account. I'm getting frustrated because I'm so worried about the time. Because I thought when I did the B, that had to be 270. Yeah, it is 270 again, isn't it? Sorry guys, I'm getting flustered because I'm so anxious about the time I've got left. I've got no time at all. So it's still the same though. So it is that. Oh my god, I wish someone, I think I need a straight answer here. So 2 by 2 matrix rotation. Because I'm getting, sorry, I'm not criticizing anyone in the chat. I'm just like, I'm getting too many bits of things. I need a clear, like, so it is that. So once and for all, let's get this goddamn, so this is 1 minus 1 0 0. Right, finally. So happy with that now. Oh, it's still not over. So find the column vector which represents the translation. Well, if we take this 90 degrees clockwise, which is the same thing, isn't it? Something very off about this. I still think I was right to say that this was 90, because what we've done is we've rotated it to there. I don't know why I didn't just draw this at the start. So that's after the rotation, which is 90 degree clockwise. I knew that was right because it was 270 from B. So it's 90 degrees that way. Sine 90. So it's that. And then the translation is -1 -3. I don't know if we were agreeing or disagreeing on that, but I think sorry, it was just a little bit too much. Like, I appreciate it's difficult to type in the chat as well, like mathematical stuff. So so yeah, right. So here, show k is equal to 5. Well, the quadratic terms, we get minus 24x squared plus k x squared, and that has to equal minus 19x squared. Well, it has to be identical, therefore k is minus 19 plus 24, which is 5, hence factorized completely. So x minus 4, and then, well, this could be 6x could be one of those. Nine minus 4, yeah. Happy with that. The diagram shows a piece of card in the shape of a sector. 14. Okay, well, it's 2 pi r, and then we're going to take a third of it. Because we're in degrees here, so times 14 divided by 3. A hollow right circular cone is formed by joining OA and OC together. So that's now 14, isn't it? Now this at the bottom has a circumference of this 29.3, and 2 pi, if I call that r prime is equal to 29.3. So r prime is 29.3 divided by 2 pi. Oh, good question, actually. I like that. 4.66. And then the height, we just do 14 squared, subtract that squared, and then root it, because it's Pythagoras in there. 13.2. Probability. Probably it rains in Loviendo. Probably not pronouncing that right. This looks a little bit Welsh or something. It is okay. So 2/3. If it is raining on a morning, the probability that she goes for a run is P. If it is not rain, the probability when it goes for a run is 4/5. Complete the tree diagram. Okay, and then follow up. The probability that she does go for a run on any morning is that. So 1/3 P plus 2/3 4/5 is equal to 37/60. Let's just not simplify. Oh, sorry, I'm answering all of this. So that's an equation in P, and then the value of P is 1/4. That means if it's raining, she's not that likely to go for a run. So that makes sense. Not guaranteed, of course, but it's always good to just check the intuition. Wow. Usually I'm happy when I see a circle theorems question, but for some reason this one looks a bit scary. So ABCD is a circle. The chords AC and DB intersect at right angles at the point E. The point F is such that AECF is a straight line. FD is a tangent to the circle. Right. Calculate the length of EF. Well, that's just 35 plus. No, it isn't. That's the hypotenuse. So 135. Subtract that and root it. So that's 10. That's nice. And then show that AE is 8. So that is the goal there. What on earth are we going to do there? Wait, what's EC? EC is 2.5. EF, I agree, is 10. But this is a little bit misleading. So that there is 7.5. This 10 is the full way along. Wow. What is going on here? I knew this one looked scary. That's theta. Then that's theta by the alternate segment theorem. And I know what theta is, or I can work it out, because it's in a right angle triangle, so that's calculable. What's it's diagram's rubbish. That there is root 135. So we got a right angle. And then same on the other side. I'm doing a lot of work for 3 marks here, but I'm not seeing a way in. DE. So whatever that turns out to be, that'll be the same. That's also theta. It's not expecting me to use that. I know there's a result, and I think it says if that's xy and that's AB, I think there's a result that says that xy is equal to AB, but I can't imagine it's expecting me to use that. I don't see any way. I can't see another way in, so let's try that. Let's call that alpha. So that means we've got the adjacent, we've got the hypotenuse, so cos alpha is equal to 7.5 over root 135. No, it isn't, it's 10, because of this horrible diagram that they've given me. So arc cos of 10 over root 135. So alpha is equal to 30.6. So this here is also equal to 30.6. That means, so what is root 35? Is it dB? So dE is root 35. Let's get a different color. This here. The alternate segment theorem says, which I don't think we need to use in this case, if you have a tangent to a circle like that, then that is equal to that. That's the theorem that I'm applying to get those theta there. What do you mean it's not? Don't really know what you mean there. BE is not a tangent to the circle. Well, no, I never said that. But BF is. But we know that 90, and then, oh, no. You're right to point something out, though. This isn't, yeah, because this doesn't bisect, yeah, because it doesn't go through the center. So this is not 30.6. Yeah, okay, I now see what you're saying. Yeah, I do agree now. Sorry, I thought you meant these values. Oh, God, I actually I don't know what to do here because Let me get rid of this, because I don't want it to mislead me. I don't know, I can't see a way in. How can you get that? You've got... This has absolutely baffled me. One thing I can think is that there's something about circles, triangles, etc. that I don't know, and they're expecting us to know it. Yeah, maybe you're right. Maybe I should move on and come back. But I really can't think of a way in, because the only thing I can think of is to use this, which I don't think it's expected that you know it. But I then don't know how to find the length of that. And for 3 marks, it should just pop out. Unbelievable. I just don't know, guys. I've just noticed that question C as well is asking us to calculate length of EB. So we should be able to find AE without calculating AB. I can't believe I can't do this. Similar triangles. Yeah, I hadn't considered that. So we're saying this. How do we know they're similar? Because they're only similar if A, B, and DF are parallel. Do we know that for certain? I don't think this helps actually, because we don't know. We would need 2 bits of information that coincide. We would either need that, or we would need that and that. We don't have that. I also don't know how we know that they're similar, because they're only similar if these lines are parallel. I mean, I'm happy to accept that they are, but I don't know if we know that for certain. I don't know if we can assume that. I'm going to come back to it, because again, I get stuck on one question and I get obsessed with it. I'm just hemorrhaging time. Oh god, another freaking triangle. So ABC is a triangle. D is the point AC such that BD is perpendicular to AC. AB is 40. ABD 62. Yep, fine. Calculate the area. Right, so we know what that is. That's 28. And then we can work out what that is. So 180 take 90 take 54 is 36. Because we're going to need that. Because we need to find AD. So let's call that X. So sine 62 equals, so 40 sine 62 is X. Why don't I like that? God, I'm just getting frustrated again. Let's do this one. Cos 28. I'm suddenly I've become quite weary again. I think that was right, but it didn't look right. Yeah, no, of course it was right. So 40 sine 62. And then we can do 40 squared subtract 35.3 squared. 353.9. It's not just Pythagoras, because we don't have 2 of the sides. All I can think about is that other question. Let's call this one y. Tan 54 equals, so if I do 18.8 divided by that, that'll give me y. So 18.8 over tan 54 is 13.65. So all in all, the area is 13.65 plus 35.3. That's the full length of the base, multiplied by that, and then divide by 2. 460.13 centimeters squared. So that's that question. That's the end of the paper. That's the end of the paper. So what the hell is going on with this? I can't let it go. See if anyone's come up with any inspiration in the chat, 'cause it's doing my head in. It should just fall out. It's 3 marks. So you're saying angle CAB, which is that, is equal to angle BCD. BCD. Nope, must have misread you there because that's way off. So CAB is that angle. Angle BCD. Oh, BDC. This angle. So these two angles are the same. I mean, if there's a property of the circle that gives you that, I'm not familiar. Oh, yeah. So that's angles in a... So, yeah, I'm happy to accept that they're the same. So, if we call this beta, and we call that beta, which means that, yeah, that triangle there is similar to that triangle there. I still don't see how it helps us. Because there's no two triangles that we have enough information about to use similarity. I want that angle. If I can get that angle, I'm done. Oh, okay. So I think maybe I've got it. So theta. Let's actually work out theta now. So what should we do for this? Tan theta. Right. Really losing track of the triangles here. So tan theta equals 10 over root 35. So theta is arctan of 10 divided by root 35. Oh, freaking. So it's about 59 degrees. Let's call it 59.4. And now beta we can work out, because this angle gamma here, which I can't believe it took me so long to spot, is theta subtract beta, and we can work out beta because it is it's in there. So tan beta is equal to 2.5 over root 35. So arctan of 2.5 over root 35 is that, which is about 22.9. So that angle there, gamma, is 59.4 subtract 22.9, which is 36.5. And now we want x. We've got root 35, and we've got that, which is 36.5. So now tan of 36.5 is root 35 over x. So give it the old switcheroo, and we've got root 35 over tan of that. So 7.99, which, yeah, that's 8 modulo rounding errors. Friggin' hell, that was hard. Really couldn't see what to do there, and I was getting all wrapped up. It actually, this thing here it's actually fairly straightforward. Yeah, thanks to, I think it was, is it Y Wong, who pointed out that is the same as that. That's by what we call the bow tie theorem. Sometimes I just got my head in a muddle there. Right, hence calculate the length of EB. Well, let's not do anything fancy. We know that that's the angle what I called gamma, which we just worked out is 36.5. Right angle EB is there. Let's call it Y, and then we've got the 2.5 down there. Equals 2.5 over Y. So give it the old switcheroo. And 2.5 over tan 36.5 equals 3.38. Now, I'm curious, is it true that 3.38 multiplied by root 35 is equal to 8 times 2.5? I'm sure this is a theorem. So if we times that by root 35, we get like about 20. Yeah, which is 2.5 lots of 8. Yeah, so this theorem up here that I was alluding to, that is a thing. Right, thank God for that. So that's that paper done. Took way longer than I wanted to. Again, it took about an hour. Just got hung up on that one question. So that is 18, page 20, and there we go. Let's get that other IGCSE paper out of the way. I just want to take a second to thank all of the donations that have come in. Thank you very much to Dr. Creams for £19.99. Perfect. Thank you so much. In fact, oh yeah, it was just the one IGCSE paper. Yeah, let's GCSE time. So we'll do this one. So GCSE paper 2, calculator. Was that just 12? So now I'm on 13. That's right, isn't it? Right. So that was the halfway mark. Even though I'm 14 hours. 14 hours in. I've got 10 hours to go. So 10 hours to do the back 12. So right, next two are GCSE papers. I want to smash through these in as quickly as possible. Just going to change the music I'm listening to. Thanks for sticking with me, guys, even while I'm being quite quiet and just trying to smash through them as quickly as possible. Right. So here we go. Oh yeah, so thank you, Dr. Creams. That was Creamer, who you heard before, the chemist. He's a researcher at Imperial College London. Thank you to the anonymous donator who donated £17.29, and thank you to Mike Taylor for the £20. Absolutely fantastic, guys. We're almost at 3,500 now. I think even if we add in the super chats that I received earlier, we won't be too far away from that. So let's get into it. So A, 2, 4, 10, and 14. Right, so it looks like we've got 8 in the middle. 20 appears in B and C. And then that's the only overlap, I think. So that we've got 18 and 22. B has 6. A has 2, 10, and 14. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But that was 10, 9, 8. Yeah, that makes sense. Okay, so a number is... Oh, and I suppose the outside as well. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So 8, 9, 10, 11, 12, 13. Nope, I think I've got a duplicate somewhere. 6. Find the probability that the number is a member of A intersect B. Well, 1 over 24, because there's only 1 in the intersection of A and B. Right. Sean has information about the height. So, line of best fit, not representative. Height in centimeters, weight in kilograms. Axes. Start. Bad. Terrible way to phrase that. Oh god, I would usually love to see some geometry. It's like my favorite topic at this level, but after that nightmare we just had, I'm kind of frightened of it. So work out the size of the angle X. Well, that there is 110, so subtract 35, we get 75 for that angle there. That angle is 45. Yeah. And then 180, take 45, take 75, 60. Okay, Northern Bank has 2 types of account, both by accounts pay compound interest. So Ali, £2,000 multiplied by 1.025 cubed, and Ben, 1,600 times 1.035 cubed. So this is an exercise in using the calculator. So 2,000 times 1.025 to the power of 3. They're going to get 2153.78. And then the other one, 1,600 times 1.035 to the power of 3. We get 1773.95. So Ali gets more. In the third year, the rate of interest for the shares is changed to 4% per annum. Does this affect? No. Because I'll just verbalize it. 2,000 times that times that squared times 1.04. Because if you divide and then times by 1.04, you're not going to grow this one to the size of the other one. Is how I'm kind of looking at it. So 5. The diagram shows a floor in the shape of a trapezium. John is going to paint the floor. Each litre of paint costs that much. 1 litre of paint covers 2 meters squared. John has £160 to spend on paint. So the area of this is 91. Oh, interesting point there. So the interest, who will get the most interest? Oh God, I'm not reading the questions properly. So that is the interest for Ali, and then this is the interest for Ben. So it is actually Ben. And then does that affect the answer? Oh God, I don't know. 2000 times 1.025 squared times 1.04. They now get 185.3, and then 1600 times 1.035 squared times 1.04. They now get 182. So yes, it does affect, because we worked it out. I don't know how you were supposed to know that, actually, looking at this, if you just want the interest. Oh God, ugh. It's just a shares account that's changed. So no, it doesn't affect, because they were already getting the most. So if they get even more, then they still win. Right, so 7 lots of 10 plus 16 over 2 is 91. So that's the area, which means we need 45.5 liters of paint, which means if we divide that by 5, we need 10 tins to cover the whole thing, which means he needs £169.90, which no, he doesn't have enough to spend on paint. Sorry, John. No Toblerone for me then. Sorry, Dad. No. So gradient of AB is 3, so that means 15 subtract 9 over D minus 5 is equal to 3. That means 6. I think my pen is running low on ink again. Yeah, definitely. I'm going to carry on in green. Where was I? 15. So add that over 7 is D. Yeah, that makes sense, because you've gone up by 2 steps, you've gone up by 6. Yep. Write the number that in standard form. So 8.623 times 10 to the power of minus 1, 2, 3, 4, 5. Okay, and then work out that 3.2 times 10 to the 3 plus 5.1 times 10 to the minus 2, 4.3 times 10 to the minus 4 is that, which is 7.44 times 10 to the power of 6. Just calculator exercise there. Oh, here we go again. More reflections. We know what a mess I've made of them last time. So, oh, and it's our old friend. I'm going to need a bigger ruler. We're going to need a bigger boat. So if I draw in, try and draw it at least somewhat accurately. Y equals minus x. And then x equals minus 1. So P is reflected in the line y equals minus x. 1, 2, 3, 4. 2. Okay, I'll just draw that a little bit bolder for you. So that there is triangle Q. Triangle Q is reflected in y equals x minus 1. So, like that this is R. Describe fully the single transformation that maps triangle that maps R to P. So this is an anti-clockwise rotation of 90 degrees about, I'm thinking that point. Yeah. So about -1, -1, 1. Okay, Martin truncates the number n to 1 digit. The result is 7. Write down the error interval for n. Ooh, interesting. So n must be greater than or equal to 7, and it must be strictly less than 8. Yeah, standard form is a funny one, isn't it? Because, you know, why is it like it's only standard in the scientific community? So Robert makes 50 liters of paint by mixing liters of yellow paint and liters of blue paint in that ratio. So yellow to blue, 2 to 3. He makes 50 liters, so that means he needs 20 yellow and 30 blue. Each tin of yellow paint costs £26. So it's 4 tins of yellow at £26. Blue paint is sold in 10 litres, so he needs 3 tins of blue at £48. Robert sells all the green paint he makes in 10-litre tins. So he sells 5 tins of green, because it's 50 litres altogether, at 66.96. Right, so he's running a little scheme here, is he? So 4 times 26. So this is 104. All right, JG. Yeah, I mean, absolutely no pressure to stay and watch the whole thing. I was really applauding the effort there, but it's absolutely totally fine if you want to hop off for a while. I will still be going here. So that's 248. That's the cost, and then he does 5 of 66.96. So sells them for that much, which means he's making. That is the profit. Is 86.4. But we want the percentage profit in each tin of paint that he sells. Oh my god, it's never easy, is it? So that's 20 liters. That's 30 liters. So if we kind of, how much does it cost to make a liter of green paint? So we've worked out it costs. Sorry, how much does it cost to make a tin of green paint? It essentially costs. This makes 5 tins. So his cost per tin of green is that 49.6 on average. That's the cost per green tin. Now he's made that profit in total. Well, we don't need that actually. We do 66.96 subtract 49.6. So that is the profit per tin is 17.36. So if we divide that by the cost per tin, and then times by 100. That is 35% profit on each tin. Yeah. Well, I couldn't just divide by 5. It was yeah, this was I think was like the less obvious. Obviously, it is just divided by 5, but I don't know. Conceptually, I just wanted to make sure it was right. Okay, in a restaurant, there are 9 starters, 15 mains, and 8 desserts. Janet is going to choose one of the following combinations for her meal: a starter and a main. Okay, so a starter and a main, or a main and a dessert, or a starter, a main, and a dessert. Sure, this should just be the answer. So 9 times 15 plus 15 times 8 plus 9 times 15 times 8 is 1,335. I think they are the sensible ways of choosing a meal. I think the starter and dessert is unorthodox. Right, so let's just jump in with that. So 2x plus 3 times 2x, all divided by 3 lots of 2x plus 3, x squared minus 3x, cancels, and then it's a bit cheeky that, isn't it? Because we're assuming that x is not 0. I think it's fine. Okay, express that in a fraction in its simplest form. So 3x times x minus 2 plus x minus 1, x plus 1 x, subtract 4 x plus 1 x minus 2, all over x plus 1 x minus 2 x. So 3x squared subtract 6x plus x squared plus x, take 4 lots of x squared, take x, take 2. So we've got 3x squared, so they die, minus x, so minus 6x plus x is minus 5x, plus 4x is just a negative x. So that deals with that, that deals with that, that deals with that. Over x plus 1, x minus 2, x. I don't know, I don't think we can simplify that any further, can we? What's that? It's minus 9, not minus 3. Oh yeah. This one. It's not really a satisfying answer, is it? It's not really in a simple form, but I don't think we can really do any. They are the factors. Just I was kind of hoping we get the same thing appearing here, so I'm just going to check my expansion. Definitely is an 8 there. I'm just wondering about the x, because minus 6x plus x x subtract 2x is minus x. So this becomes a plus 4x. Yeah, it is. I can't see any way to simplify that any further. Oh well. Okay, so 13 shows a circle and an equilateral triangle. One side of the equilateral triangle has that diameter. The circle has that circumference. Work out the area of the triangle. So C equals 2 pi r, and we get 44. So if we divide that by 2 pi, we get the radius. Oh, 44 over 2 pi. That's approximately 7.002, which if we double, 14.006. How's that? That must be 3 there. Yeah. So that's D. So that's this 14.006. I'm kind of leaving myself some wiggle room just in case we get a rounding error. So we want that given that. Or we could do half 14. Yeah, so if we do 14 half times that squared times sine 60, which is like root 3 over 2, isn't it? So if we do it's that, so 0.5 times that squared sine 60. So 84.9, I think, is the area there of the triangle. Centimeters squared, obviously. So yeah, I think there's a way of, I can't remember what it is. Is it just like root 3 times the base is the I used to know this because it's good to know all these little tricks for what, you know, if you're doing like those Olympiad type questions, or you have to do like those kind of puzzle papers that you need to go fast on. It's good to be able to just like, if you know one length of the of an equilateral triangle, then you can instantly find the area without having to mess about like I did. So on the grid, sketch the curve with that equation, and that is going through at 1. So just a standard sort of exponential shape. The equation with the circle that, find the radius of the circle. I've got a feeling that's 7.5. No, it can't be 7.5. I've seen that number before, I'm sure. 0.25. Sorry, root of that. 6.5. Okay, there are only red and blue counters in a bag. Joe takes a random counter from the bag. The probability that the counter is red is 0.65. Joe puts the counter back in the bag. Mary takes a random counter from the bag. She puts the counter back in the bag. What is the probability that Joe and Mary take counters of different colours? Well, it's 0.65 and again, plus 0.35 and again. So 0.65 squared plus 0.35 squared equals 0.545. There are 78 red counters in the bag. Well, we know that 78 divided by 78 plus blue is equal to 0.65. 0.65 times 78. So if that goes up there, then we do 78, subtract that, and then divide by 0.65, 42. So that means that there's 120 in total. Yeah. Okay. P and Q are numbers, such that P is greater than Q. When you subtract 5 from P and subtract 5 from Q, the answer is in the ratio 5 to 1. So P over 5 over Q over 5 is equal to 5. Now, when you add 20 to P and add 20 to Q, the ratio is 5 to 2. Find the ratio P to Q. Sorry, someone correct me on that one. Oh yes, it asks for different. So 1 minus that is the probability that they're different. Yeah, sorry. Yeah, just totally misread the question there. Thanks for pointing that out. So yeah, just kind of losing track of what the whole point is. I want to derive P over Q. It's quite tricky. I guess I could just solve the system. I think I'm overthinking this. Why don't I just solve it? So if I do this one, subtract this one, I get P is equal to 80. And then I get 80 minus 5Q is equal to negative 20. So Q is equal to 20. Does that make sense? 160. Yep. So P to Q is equal to 80 over 80 to 20, which is 4 to 1. Yeah, I'm kind of overthinking that one because I was like, surely it's not going to let me just find them because then it's just obvious. But like, because sometimes you actually need to form the expression in a clever sort of way. So line L1 passes through there, L2 passes through the origin and has great. So line L2 has y is equal to negative 3x. That's the equation of that. And they intersect at point P. So L1 now, it has gradient 2 minus 6 over 12 minus 4. So that's minus 4 over 8, which is minus 1/2. And then y minus 6 equals minus 1/2 x minus 4. That's the equation of line L1. And then I might just stick minus 3x in there. 6 is equal to minus 1/2 x minus 4. So now minus 6x, take 12, is equal to 4 minus x minus 5x is equal to 16. X equals 16 over 5. And then times that by 3, y equals negative 48 over 5. I knew this wasn't right. Oh, thanks so much, Rasheen. I suppose you're up with the little ones. That's yeah. Thanks very much. Cheers. Sorry, yeah, kind of distracted here, but yeah, thanks so much. Where have I gone wrong here? I don't think it's a sign error because that minus 1 I've just folded inside there. 5x equals 2 minus 6 over 12 minus 4. Happy that that's the gradient. Let's do it the other way, just as a bit of a sanity check, plus c. And then we can put in 6 is equal to minus 1/2 of 4 plus c. So this is 6 is equal to negative 2 plus c, so c equals 8. So minus 3x is equal to minus 1/2 of x plus 8. So negative 3 plus 0.5. So minus 2.5x is equal to, it's going to be the same. Oh, but it's negative. Ah, that's the sign error that you were talking about. Perfect. Okay, thank God. So minus 16 over 5, 48 over 5. Yeah, sorry. Yeah, you're absolutely right. Slash, I think you were the first to point that out. I thought it was this. But yes. God, it's amazing, guys. You're probably looking at this thinking I'm an idiot, but trust me, once you've been doing this for like 14 hours straight, it's amazing the kind of stuff that you miss. This is the kind of stuff that's like, God, I like the students that I teach. I'm like, oh, come on, pay attention. How can you have missed that? You know, but it's trust me. So 88 is less than m squared plus 7 over that's 128. So subtract 7 from all of those. 81 is less than m is less than 121. So that means, ooh, I don't want to root that. 9 is less than m is less than 11. But also, I want to say this. That's got to be right. Surely it's just that. This, if and only if this, if and only if this. It's got to have a square between. Yeah, I think this is the answer. Yeah, you're absolutely right. Yeah, sometimes you just you get so wrapped up in it. It's easier than what you're making it. I'm wondering why this is 5 marks. I don't know if someone wants to correct me on this, but I just think that's got to be it. Anyway, oh, a frustum, I believe it's called. Oh yeah, here is the frustum of a cone. So we've got, the diagram shows that the frustum is made by removing a cone with height 3.2 from a solid cone with height 6.4. Okay. The frustum is joined to a solid hemisphere of diameter 7.2 to form this kind of weeble shape. The density of the frustum is that. The density of the hemisphere is that. Calculate the average density. Oh my God. So, obviously we're going to look at some volumes now. So, well, this cone as a whole is similar to this cone. So, in fact, we know because it's half the height, it must be half the base. So that's 3.6 centimeters straight off the bat. Now, to form the V of the volume of the frustum is going to be the volume of the big cone, subtract the volume of the cone that we've chopped off, which is it's pi r squared h over 3. So big cone is pi 3.6 squared times 6.4 over 3, subtract pi 1.8 squared times 3.2 over 3. Let's get our hands on that, because we're on decimals, so we don't need to worry about pi or anything. So let's do 3.6 squared pi times 6.4, subtract 1.8 squared pi times 3.2 all over 3. So 76. So that's the volume of the frustum. Now volume of the hemisphere is volume of the hemisphere is just 4 pi r cubed over 6 because we're dividing it by 2. And now this is 4 pi, the radius is 3.6 to the power of 3 over 6, which is 97.7. So density is equal to mass over volume. So the density of the frustum first, this is 2.4 times 76 will give the mass of the frustum. So we'll work that out. and then we'll have 4.8 times the volume of the hemisphere, and that will give the mass of the hemisphere, and we'll work that one out as well. So 2.4 times 76 is 182.4. 4.8 times 97.7 is the mass of the hemisphere, which is 468.96. So they are the masses, which means the total mass plus 182.4. So the total mass is 651.36 divided by the total volume will give us the average density. So overall big rho, if I do that thing divided by 76 plus 97.7 is 3.75 grams per cubic centimeter. All right. And that is the, not the end. We've got more questions here. Oh, one more question. Oh, God, I'm having flashbacks to that IGCSE paper. So, A, B, R, P are 4 points on that circle. A, O, R, C, 4 points on a different circle. Two circles intersect at A and R. Prove that angle CAB is equal to angle ABC. Okay, so big question. Thinking about this. Shouldn't think about that. We don't know that that's 90. Well, here we go again. God, what is it with these today? Usually these are like my favorite questions. But again, I'm just struggling to find a way in. Okay, I might have an idea. Let me just get rid of some of this. So I'm looking at this now. Where's my ruler or whatever I was using as a ruler? So I'm looking at this because that is also a radius, which means that is equal to that, which means it is true that those angles are the same. And then, oh God, I had an idea then, but I've lost it. Yeah, I've lost it. Let's call it theta. That is also theta because it's an isosceles triangle. And then this here is 180 minus 2 theta, which means that is 2 theta. We've got a cyclic quadrilateral here in the form of CROA. So that is also 180 minus 2 theta, because the sum of the opposite angles of a cyclic quadrilateral add up to 180 degrees. And now we've got the big triangle ABC. So we don't know what that is yet. We'll call it X, although I think we know what it's going to be. We have to have the case that 180 minus 2 theta plus X is 180. Yeah, dies, and then we get minus theta plus X is equal to 0, X is equal to theta. Yes! Oh, good question. God, yeah. Good question. Okay, and that's the end of that paper. Zach, thanks very much for your donation. Sorry I missed it. I'm just I'm in full speed maths mode here. But thank you very much for the donation if you are still watching. I really do appreciate it. Okay, I'm going to power through another one. We are now on exam number 14. This is a GCSE paper 3. Huge thank you to everyone who's sticking with me. Thanks to the old man as well. It's actually really nice and convenient the time zone works out. The fact that usually the quietest part of night is when you're it's like the kind of normal sort of evening for you. But I really do appreciate the fact that you're with me every step of the way here. So let's power through this one. So, correct to 3 significant figures is that. Oh, I've missed some questions. No, I haven't. This is question 1. Of course it starts at question 1. So, work out that and write all the figures on your calculator display. What a waste of question. 17 plus 16 over 7.3 squared. Absolutely tedious. What? Write down all the figures on your 107798136. Fine. Last year, Joe paid £245 for her car insurance. This year, she has to pay £883 for her car insurance. Ooh, Joe must have had an accident or something. So it's increased by that, which as a percentage increase, so it's gone up by 260%. Not great. Do the exams get more difficult? Yeah. So I've got a run of a few of the simpler papers just because I'm trying to catch up. I'm currently 13 papers down, but I'm almost 15 hours in. So I've got a run of the more straightforward ones. I'm doing some of the A level after this, and then I've got a couple of tricky ones that we're going to do towards the end. So to test, you are using the right calculator. Yep, it's a calculator. So not quite sure what you meant by that, Turtle. So, yeah, exactly. Just get rid of the car. So 0, we get minus 4 there. When it's 2, that is 2. 3 squared is 8. And then by symmetry, that one also must be 2. On the grid, draw that graph. Now, this sounds very familiar. I did one of these earlier today. So x equals minus 3y. Oh, I've got an awful scale on here. Minus 3, minus 2, minus 2, minus 1, minus 4, 0, minus 4, there, there, like that. So it's going to look something, let's start. Along those lines. Use the graph to estimate the solutions. So it looks like minus 2.5-ish and 1.5-ish. Ish. Big-ish. Oh, right, okay. No, I think it just wanted to, basically, if you write down all the digits, then it's like a guarantee that the student knows how to use a calculator. It is a very weird question, though, I'll admit. But yeah, that is an interesting point. So Fran asks 40 students how many books they bought last year. Wow, where are they finding these students? I don't know many students that are buying this number of books. The chart shows information about the number of books bought by each of the 40 students. Work out the percentage of these students that bought 20 or more books. That's 2 out of 40, which is 1 out of 20, which is 5%. Show an estimate for the mean number of books. Oh, show that. Well, I'll just put the graph on there. If we assume that these are like two books in that bucket, and then this is plus 7 of 8, plus 12 of 13, plus 17 of 6, plus 22 of 2, and then divide the whole thing by 40, that will yield an estimate of the mean. So 2 times 11 plus 7 times 8 plus 12 times 13 plus 17 times 6 plus 22 times 2, 40. 9.5. Which, looking at the data, I think that looks about right to me. 9.5, that looks like it's the center of mass of all of those bars. Lara is a skier, so she did it in 104 seconds. The race was 475, 114 seconds. Lara assumes that her average speed is the same for each race. Using this assumption, work out how long it should take to complete it. So her speed is 475 over 114 meters per second. Over 114. So that's the speed. And then distance equals, distance over time. We want the time, so we need to do 700 divided by that. 168, which is 2 minutes and 48 seconds. Lara's average speed actually increases the further she goes. So she gets faster, so smaller on the longer distance. Thanks, Shiro. I managed to catch that one in time. But thank you. So AC is 40, angle C. The size of angle B. Right. So angle B over angle A is 3 over 2. So if we call the angle A theta, then this here is like 1.5 theta. Calculate the length of AB. Let's call it x. So we can actually just work out. So 2.5 theta is equal to 90. Oh, I thought this was going to be more technical. Divided by 2.5, that's 36. So let's do cos cos 36 is equal to 14 over x. So 14 divided by cos 36. 17.3 centimeters. The table gives the speed, draw a frequency polygon. So, frequency polygon. What is a frequency polygon? Because this genuinely this doesn't exist on the specification anymore. It's kind of forgotten. Do you draw it at the halfway? Do you draw it like that? I actually genuinely don't remember. 26 and 12. Oh no, I think what we do is, I think maybe just bars. This doesn't feel right. This doesn't feel like a frequency polygon, but I genuinely can't remember what a frequency polygon is. What I've drawn there is basically a histogram. I think maybe what I wanted to draw was something like that. But I genuinely can't remember, and I can't. Feel free to correct me, but I'm not going to go back and fix it because I can't be bothered. So, cuboid. The metal cuboid is melted and made into cubes. Each of the cubes is length 2.5 centimeters. Work out the greatest number of these cubes that can be made. Wow, actually quite a deep question here. So my gut is telling me 9 by 5 by 3 by, yeah, 9 by 5 by 3 there. Because they have to be whole numbers. So 27 has to basically, we're forced into 9 by 3 by 27. Because the other option is 27 by 1. However, usually you get more volume out of the like a more closer to a sphere, because at 27 by 1 would basically mean a very, very thin cuboid like this, which is going to have a lower area overall, a lower volume overall, I should say. I think. I guess we might need to try it. So if it's this, we get 135, I think. 3 times 5 times 9. If it was 27 by 1, then that would have to be 15. But then there's nothing you could times 27 by to get to 45. So I think this has to be it. But then what is that greatest number about then? I guess we'll find out. So if we're making cubes, each length 2.5, so the volume of those, oh, this is where the greatest thing is. So 2.5 cubed, cubed is 15.625, and then 135 divided by that is 8. So because we want an entire cube, 8 is the answer. Yeah, quite an interesting question, that one, actually. Okay, expand. Oh, it's a cubic, so 2x squared. Take 4x plus 3x is that's 6, and then times by x plus 1. So I've got 2x cubed minus x squared, subtract 6x, plus 2x squared, take x, take 6. So 2x cubed plus x squared, take 7x, take 6. So we've got 4y to the 4 plus n subtract 2 is equal to minus 5. Okay, and give our solutions to 3 significant figures, which is a big clue that we're going to need to use the quadratic formula, which I'm going to use the function on my calculator for. So 5 minus 4 minus 3. X is equal to 1.27, and x is equal to minus 0.472. You would definitely get in trouble if you did that in the actual exam, but I'm in a rush here, so let's just make peace with it. So f of 23, this is basically asking, do you understand what function notation is? Which of course we do. 1.56. G of x is equal to that. So if I do g of 34, that's going to be 65, isn't it? And then 4 sine of that, 3.63. And then h of x is equal to that. Ivan needs to solve the following equation. He writes this. Correct? No. Because at that step, it could be that x plus 4 is equal to negative 5. So you would get another solution of x is equal to negative 9. That would be another valid solution. Sketch the graph of y equals tan x. So, asymptote at 90, asymptote at 270, and then we're going to blow up, and then we're going to go through 180 and blow up again, and then we're going to come in there. Not bad. Yeah. So interesting chat about that cubes question. Yeah. So yeah, volume is preserved. I think it would be a more interesting question if you'd actually tried to chop it up, but I think the answer would be different. Maybe in this case it would be the same, but not in general, because the slicing it up is more restrictive. But yeah, interesting thought. So AB is 5. This is a square base, so that's 5 as well. The vertex T is 12 above the midpoint of the square at the bottom there. Calculate the angle of TAC. So we want that angle there. Let's call it theta. So that means that sine theta is equal to 12 over... no, that 5 there does not relate to that. Right. So this hypotenuse is root that side there. Let's just sketch this. 12. I think that this is root 50 over 2, and that's theta. Let me just double check that, because I've done that quite quick in my head. 5 squared plus 5 squared, and then root it. That's the hypotenuse, and then divide by 2. Let's use that form. 5 root 2 over 2. Right angle, that means tan theta is equal to 12 times 2 over 5 root 2. So theta is equal to arctan of 24 over 5 root 2. Oh, that's tan. Oof, that was almost a costly error. 73.6 degrees. The number of animals in a population at the start of the year T is PT, that says there actually. That's actually incredible. I mean, I can barely see that, so you guys have probably got no chance. The number of animals at the start of year 1 is 400, and then we have that recursive relationship. So P3 is equal to 1.01 P2, which equals 1.01 squared P1, which is equal to 1.01 squared times the initial is 408. I mean, I'm going to say 0.04, but I think 408, that's the number of animals, really. They don't increase very much, do they? It's quite a stable population, because you can't really have 0.04 at the 0.04 animals. I hope not, anyway. So y is inversely proportional to 1 over... Sorry, it's directly proportional to 1 over x cubed. So yx cubed is equal to some constant of proportionality. When y is 44, then x is equal to a. Okay, and then when... Oh, show that when y equals 4.5... So 5.5 x cubed is equal to 44a cubed. 44 divided by 5.5 is that, which is 8, which is, yes, this is good. X cubed is equal to 8a cubed, therefore x is equal to 2a. No sign blunders there because we are cube rooting, so don't need to worry about the negative case. There isn't one. Prove algebraically that the difference between the squares of any two consecutive odd numbers is always a multiple of 8. So let n be odd, then n is equal to 2k plus 1 for k an integer. So the difference between an odd number, well, let's start with the 2k plus 3 is the odd number that's after that. Oh, between the squares. We have to show that this is a multiple of 8. So 8k squared plus 12k plus 9. Subtract 4k. Subtract 4k squared plus 4k plus 1. And this is equal to 8k minus plus 8, which equals 8k plus 1. That is an integer, which means this is a multiple of 8. Here is the here is a shaded shape. Wow, what on earth is that? What is that? What does that remind me of? I've got a feeling I've seen it in, like, I'm thinking of a film, or I'm thinking of like a game or something like that, where someone has like a very sharp helmet, like a kind of medieval helmet, but with a big spike at the front. Maybe Game of Thrones or something like that. I'm sure that this is what... anyway, sorry, my brain's conjuring all sorts of images here. The shape is made from a triangle and a sector of a circle of radius 6. OCD is a straight line. Angle AOD is 140. Angle OAD is 24. So we can work this out if we want to. Calculate the perimeter of the shape. Holy moly. Okay, so this here is 220, isn't it? So that kind of the big arc around the outside is going to be 2 pi r times 220 over, it's that fraction of the whole circumference, so that's fine. Now what about this? I want that, and I want that. Oh, we get that. Sorry, 14. Right, both of my pens are out of ink here. Let me just finish this question with the blue pen. So we actually get that, which is AD is 14. Right, and that's the way in, because now if we call OD, if we call that X, then X is equal to 14 sine 24 over sine 140 by the sine rule, or rule of sines, I think you call it in the US. To any US viewers, rule of sines. Is it law of sines you call it? Someone will correct me on that, no doubt. We just call it the sine rule. So this is 8.859, And now if we subtract the 6 from that, we get this here is 2.859, which is smaller than it looks. But again, can you really trust the diagram? X over sine 24 equals 14 over sine 140. Can't see why this isn't right, but it just doesn't look right. But I think we're just going to need to make peace with that. So 220 times 2 times pi times 6 over 360. That gives us this bit here. So this is 23.04. So altogether, we've got the 23. Let's do it on the calculator. So I've got the 23.04. That's the arc out there. And then we've got plus that 14 plus that little 2.859 equals 39.9. So that plus that, kind of whatever, it's that. I can't see a mistake here, but it looks a bit funky, doesn't it? But I think it's just because the diagram isn't really drawn to scale. I mean, is that really 140 in there? A little bit. It's actually a little bit bigger than 140. But you know, if anyone thinks I've made a mistake there, please feel free to correct me, because I really don't know where it could be. Right, let me just finish this paper before I re-ink the pens. So the table shows the information about the distances 570 students travel to a university. Draw a histogram. Oh god, I hate histograms. Okay, so the width of the class is 20, 30. So our frequency density is going to go here 6, 3, 30, which means 4, 70, which means 2. 50, which means 2. So 1, 2, 3, 4, 5, 6. Yep, there's enough room to just go up 3, 4, 5, 6. So sometimes they're a little bit funny about how they set this up, because they want you to be clever about how you use this scale, but they're giving us enough space here. So this is our frequency density, and then we want 20. So just a thin bar here that goes up to 6. And then we want from 20 up to 50, and this is going to be at height 3. Fiddly, this one. And then at height 4, that goes all the way up to 80. Yeah, each of these little squares is 5, isn't it? Because it's 10 little squares for 50. So if I want to go 30, I need to go across 6 squares. That's what I did there, yeah. So we should see it starting to come together. Using a pen. So we've done that, we've done that, we've done that. And then this one, it goes all the way up to 150, but it's only got a height of 2. So it's going to be there and finishes there. So blah 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 blah. And then the last one is 150 all the way up to 200 at the same height. So something like that. That's our histogram. Estimate the median distance. Well, 570 students. So 570 divided by 2 is 285. So where is the 285th value? It'll be in there somewhere. If we subtract 120 and subtract 90, it's the 75th value in there. So 75 over 120 of the width 30 divided by 120 times 30 is that way along. Yeah, just over half. Yeah, that makes sense. And then add the 50. I think, yeah, 68.75. Yeah, I can believe that. That's, you can see how that's going to kind of chop the area in half. Okay, a high-speed train travels a distance of that. So we can calculate the speed. The distance is correct to the nearest kilometer. The time is correct to the nearest minute. Okay. So speed is distance over time. That's 180 minutes. So the upper bound for the speed is given by the upper bound for the distance divided by the lower bound for the time. Now that's to the nearest k. So this is going to be 487.5 is our upper bound. And then the lower bound for the time is it's the nearest minute. So this is going to be 179.5. So by minimizing the numerator and maximizing the numerator and minimizing the denominator, we're going to get the upper bound for the speed. So 487.5 over 179.5. So that's 2.715877437 kilometers per minute. Now the lower will be the lower distance divided by the upper bound for the time. So that's going to be 486.5 divided by 180.5. 2.69352. Right, so we can see that if we round at 2 or 3 significant figures, we get different answers. But if we round to 2 significant figures, 2.7 to 2 significant figures is the answer. And that's kilometers per minute, which is a very bizarre unit choice, but there we go. Not going to argue with that. Solve algebraically these simultaneous equations. That should be the last question, right? No, one more question after it. So let's do it this way. Let's do it the old x equals 1 minus 2y, which means we're going to do 2 lots of 1 minus 2y all squared. Subtract y squared is equal to 17. And then this is equal to 2. 1 minus 4y plus 4y squared. Subtract a y squared is equal to 17. So all in all, we've got 2. Subtract 8y. That's 7y squared is equal to 17. That looks absolutely horrible. I hope it simplifies. So 7y squared. Subtract 8y. 2. That's 15 is equal to 0. Time for the calculator here. So y is equal to 7 minus 8. Might actually factorize, because we might get, yeah, 15 over 7 and minus 1. And then if we do 1 subtract 2 of 15 over 7, x is equal to minus 23 over 7. So that's the solution. And then x is equal to 3 is going to be the other solution, isn't it? 1 subtract 2 of minus 1 is 3. So that's the other solution. Let's just check it. So 2 lots of 3 squared, subtract 1, that's 17, so that one works. And then 2 of 23 over 7 squared, take 15 over 7 squared. We want that to be 17. Yes. So that's right. So 20, final question of the paper. Triangle A is transformed by the combined transformation of a rotation of 180 degrees divided by the point minus 2, 0. Okay, so we can already see where that's going to be. 180 degrees around that point. The triangle is going to be mapped to here. Followed by the translation minus 3, 2. 1, 2, 3. Oh, so it actually goes like there. On 1 point on triangle A is invariant under the... Oh, no, this doesn't look good. Because I've calculated that 2 points are invariant. Ah, but... No. That point there gets mapped there, which ends up there. They end up flipping around. No points are actually invariant. Minus 2, 0, 180 degrees. Definitely goes there. I am lost. 1 point on triangle A is invariant under the combined transformation. Oh, it's the friggin' point in the middle, Jesus. So, yeah, because it's not a vertex, is it? Wow, massive brain fart from me. So, minus 3.51. Jeez. Oh yeah, Bracco, thanks. I just got there before you pointed it out. Sorry, in my head, again, this is the sort of things that happen when you're 15 hours into this sort of thing. You really just overlook stuff like that because you get tunnel vision. Okay, so that was exam paper 14. So we've done 14, and we're 15 hours and 20 minutes in. So it's not looking as hopeless as it was. So we're going to do, next paper is going to be A-level, it's going to be an old specification A-level. And this is going to be the core 1, which is a pure paper. So these are actually the kind of exams that I used to do when I was a student. I am just going to take a short break here just to stretch my legs. And definitely need to refill the ink in my pens. So I'm going to take my ink over there just because I want to stand up while I do it, because I really need to stand up for a little bit. I'll be back. Probably not too long, probably just at like past or something like that. So I'll just have like a break for 10 minutes or so. I'll just put my board up here. Apologies that no one is around to keep you company. I'll try and make it a short break. I think James did say he was going to come back on at 4 a.m. Absolute hero. He is my statistician friend. I think he was on the chat briefly before. Oh, not David. Thank you very, very much. Now, not David. Now, just before I take the break. So I think he is a fellow Summer of Maths Exposition 2 YouTuber. And I really, really enjoyed his first few videos. Now, his most recent one is absolutely fantastic. So if anyone's not checked out Not David, please go and check him out because he's really, really good. His animations are incredible. I think it must be Blender or something that you use, but really, really awesome animations. And God, you've got a dreamy narration voice, I have to say. You know, I think if you put a bit of work into it, you could become like a voice actor or something. You've got a very, very nice voice. I hope you don't mind me saying. So yeah, excellent videos. And thank you very much for the super chat there. The proceed will go to Mind, of course. And yeah, thanks very much for that. So please check out Not David if you haven't done so already. It's such a good question in the most recent video. I have to say, which was the as I'm demonstrating right now, how much people when they are public speaking, which is it's just such a good idea. So yeah, unfortunately, you have caught me at the time when I'm just about to take a quick break. Let's give myself 10 minutes or so. So I'm going to be back at 03, let's say 34. And this is BST if you want to do the conversion there. So I'll be back in about 10 minutes. Thank you for keeping me company. I'll be back shortly. Yeah, sorry to ruin the chair stream, guys. I think we had this this joke last year actually. So yeah. Oh well, you'll just have to put up with me instead. I apologize. So, whew. Okay. Surprisingly, don't feel too tired yet. I think it will definitely start. I've got quite a lot of energy still. It'll definitely start to hit me later. I've got absolutely no doubt about that. Just trying to pick a decent album to put on here. In fact, I want to listen to something that's only. Yeah, I think it is a standard stream thing, isn't it? Yeah, James, I think will hopefully be on in about 25 minutes. So I don't want to listen to some music that I'm going to get too invested in. Um, uh, so, oh, remind me if I'm having trouble. If ever James comes online and it sounds like I'm talking to someone and you can't hear him, it's because I've not unmuted Discord. So someone please remind me about that. Right. So I'm gonna actually try and 25 minutes. Do you reckon we could do this in 25 minutes? Because this is quite an easy paper, or it certainly was when I did it. So I wonder if we can do it in 25 minutes before James arrives. Anyone want to take that bet? Alright, you see how easy this is. So, 25 to the half is 5. I've updated the exam counter, yeah. And then 1 over 125 for the next one. Doesn't get much easier than that. So that's x to the minus 3. So dy by dx is going to be 10 x to the 4th minus 3 x to the minus 4. And then the integral 2x to the power 6 over 6 plus 7x plus x to the minus 2 over minus 2. Don't think I really need to simplify that because you can't really, apart from maybe cancelling that 3 down, but that's fine. P and Q have those coordinates. The line is L is perpendicular to PQ, so we've got like minus 1, 6 is P, and we've got 9, 0. Okay, so the gradient of PQ is like 6 take 0 over minus 1 take 9, which is minus 6 over 10, which means L has gradient 10 sixths, which is 5 thirds. And it passes through the midpoint. Now the midpoint there is 3, and then the midpoint there is 4. So it's going to be y minus 3 is equal to 5 thirds x minus 4. I guess we will simplify. Yeah, we need to put it in the correct form. 3y minus 5x feel like I've slipped up here somewhere. Let's just check it. So 3 of 6, take 5 of minus 1, take 29. Yeah. Already, I feel like I've made a mistake. I'll tell you what I didn't like. 6 minus 0. Add 20, so minus 11 there. So if I instead add 11, sorry, take 11. Someone help me. It is positive 11. Yeah, so if I add 11 to that instead. Oh, why is it not working? For goodness sake. Oh no, because they are not on the line. Yeah, so I should never have expected. Yeah, so this is actually I'm still fairly sure about that. Oh, Shiru, you agree as well. Okay, that's good. You seem to be pretty on the ball, so I'll trust you. So x is equal to 2 minus y. Oh, we just done one of these. 4y squared subtract 2 minus y all squared is equal to 11. 4y squared subtract 4 take 2y take 2y plus y squared is equal to 11. So 3y squared, when all is said and done, is plus 4y there, and then minus 4 take 11 is minus 15, is equal to 0. So I reckon this one does factorize. I've got a feeling about this. Is equal to 0. So it's going to be, what, 3 and minus 5 plus 3 on that side and minus 5 on that one? Yeah, 9y. Good. So y equals 5/3, y equals minus 3. And then if we do 2, subtract 5/3, 2 subtract 5/3 is a third. 2 subtract minus 3 is 5. So that pair and that pair. Oh, Douglas, thank you ever so much for your super chat. All super chats will go to the charity Mind, so please keep them coming. I will make sure that all of those go to charity. As I said at the very start of this, I don't intend to make a single penny from this stream. So please, yeah. So thank you for that. Yes, on the first question, I think I did forget about the plus C, but yeah. Yeah, I mean, that's a bad habit of mine, actually. If we're being fair, yeah, let's stick that in there. Now another MOG video. Yeah, I'm very much working on the next MOG video. I'm just gonna start filming it as soon as I've recovered from this. I've got the script written, I've got the props made, it's all good to go. But I've been spending a lot of time preparing for this. So yeah, so it did have to go on the back burner ever so slightly. So I've actually got 2 videos I'm planning to film very soon, so I hope you're excited for that. So A, write down an expression for A2. So A2 is equal to 5k plus 3. B, show that A3 is equal to that. Well, A3 is equal to 5 lots of A2 plus 3, which is equal to 5 lots of 5k plus 3, which is equal to 25k plus 18. And now C part 1. Find the sum of those. Well, I'm not going to do anything clever here. The first one plus the second one plus the third one. And then this one, if we times it through by 5, 125k plus 90, add 3. So, how much k have we got? 156. And then how many of these have we got? We got that's 27 plus 90 is 117. Just gonna check that. 3 plus 18 plus 90 plus 3, 114. Yes, because 3 plus 3 is 6, not 9, of course. And then part 2, show that that is divisible by 6. Well, this is equal to 156 divided by 3 divided by 6 even is must be 26. Why I'm not using the calculator? Yeah, 26. And then 114 that is going to be 19. 114 divided by 6, 19, which is a multiple of 6. Well, no one is minding the bag, Douglas, but you just got to trust me, because I didn't realize you could actually link fundraisers to YouTube. So basically, I'm just going to go through at the end. I'll add up the super chats that I've made, and then I will make the transfer, which I'll just call super chat. But the super chats are publicly available, so you'll be able to verify for yourself if you're that suspicious. This is 6x to the half. Now 5 halves subtract 1 is 2. Yep, so plus 3x squared. B. Now, given that dy by dx is equal to that, and that, find y in terms of x. So, if we integrate that, we will get y is equal to the integral of 6x to the half plus 3x squared dx. Don't worry, guys, I will not forget about the plus c this time. So this is 3 over 2 divided by 3 over 2 plus 3x cubed over 3. We get a bit of cancellation here. 2 times 6 is 12 divided by 3 is 4. X to the 3 over 2 plus x cubed. Almost forgot about the plus c. Not going to lie. So 90 is equal to 4 to the 3 over 2 plus 4 cubed plus c. Now 4, that's 8 times 4 is 32. Plus 64, which is 96, which means c is negative 6. Let's just write in those. So y is equal to 4x to the 3 over 2 plus x cubed subtract 6. Oh, thanks, not David. Or David, I guess, I don't know. Yeah, it's no, it's really awesome. I've been really pleased with. Oh, I've also got a donation from Regine Nabid. I hope I'm saying that right. Thank you very much for your donation. I'm not sure I thanked you actually, which I feel is quite rude. I do really like to thank everybody who does donate. So thank you very much for that. F of x is that. Find the discriminant. So this is k plus 3 squared minus 4 times 1 times k. So k squared plus 6k minus 4k plus 9 equals k squared plus 2k plus 9. Show that the discriminant of f of x can be expressed in that form. Complete the square. Plus 8. And show that for all values k, it has real roots. Well, real roots if the discriminant is greater than or equal to 0. Why is this always greater than it? Yes, so because k plus 1 all squared plus 8 is greater than 0 is true, because that is a square, which means it's greater than or equal to 0. So of course the whole thing is greater than or equal to 0. I'll do. Question 8. On separate diagrams, sketch the curve with these equations. Right. So if we do f of 2x, we are going to kind of stretch out. It's going to go through 6 minus 1. It's going to go through, sorry about the ugly diagram. It's going to look kind of squashed like that. It still go through the origin though. I think there's something on my board there. And then, so this one was A. So x direction, we're kind of oh no, this is wrong. This is wrong. Apologies. Actually, what it should look like is we're squashing it. My bad. Serves me right for being in such a hurry. So, someone in the chat's probably already corrected me on that. No, not this time. Just got ink all over me there. So, half of that. So this goes through there. 3 over 2 minus 1. And at 3. So it's actually compressed. So it's going to look like that. I did consider doing a step paper. I think next year I might do that as a bit of a challenge, but step papers can be tricky. I do look at them because I tutor people who are sitting the step and exams like that. They are good papers. There's some really good questions on there. So if we take negative f of x up here, sorry, then it's going to just flip in the x-axis. So this is going to become 3, 1. That stays at 6. So we just invert this whole parabola like that. And then y equals f of x plus p. So we'll do that one over here. Get a little bit bigger. So if we add p, that means we're sliding it, or translating it. So p is positive. So this will be somewhere over here. This will be like 3 minus p minus 1. So it's going to look the same shape as it was before. And then this will be 6 minus p. And this will be 0 minus p, which is just p. Minus p. So just the whole thing just slips to the left. Yeah. Oh, I just read my dad's comment there. Yeah, the diagram is absolutely not to scale. I apologize for the crudity of these diagrams. Oh yeah, that's made me laugh. My dad and I, we absolutely adore Back to the Future. We watch them every time we get together. It never gets old. It's just such a good film. All three of them just so good films. No one else probably no one else gets that reference. Okay, so the sum of all the even numbers from 2 to 100. Well, we could do this the Gauss way and do 102. No, let's just do 2, 1 plus up to 50, which is 2 lots of 50 times 49. No, 51. N plus 1 divided by 2, so cancels, and then this is going to be 2,550, is it? Yeah. All right, B, part 1. The arithmetic series that k is a positive integer and k is a factor of 100. Wait, k, 2k, 3k, and then finishing at 100. What's going on here? So for example, k equals 5, we've got like 5 plus 10 plus ... plus 100. So this is finishing on 20k basically. Right, okay. I get it. Find in terms of k an expression for the number of terms in the series. So 100 over k, because this is giving 20 terms. So 100 over k is the number of terms. Show that the sum of this series is that. So this is the sum. Let's call it n equals 1. So this is of kn up to 100 over k. This is weird. Let's pull the n out. So this is from n equals 1 to 100 over k of k, which as we know is 100 over k times 100 over k plus 1. But I'm going to write that as plus k over k. And we're timesing by n. Sorry, we're timesing by k. Sorry, I should have pulled the k out because n is the variable that's in there. So this is now correct, I think. No, I don't like this. Maybe it'll work out. It's not going to work out. This is nothing like what they've got there. I'm going to start this one again because feels right. Oh, I'm missing the half. Oh yeah, n times n plus 1 all divided by 2. So if that's 2, then we get 5,000 over k. This looks good actually. Oh, plus 50. Oh yeah, thanks. Oh, thanks for that, David G. Yeah, massive. I was looking at this thinking this is right. I was sure of it. So just a massive blunder there. Obviously, you times it's n times n plus 1 over 2, as I demonstrated there. Energy Man, thank you very much, all the way from Brazil. Thank you so much for the donation there. Really appreciate that. Just passing through. We've also got question C here. I just want to make sure I do that before we move on. Find the 50th term. So n is 1. So n is 1, n is 2, n is 3. So basically, it's going to be 100k, the 50th term. And then what's the rule here? We are doing 3n minus 2 to get the constant 3 times 2, 3 times 3, yeah. So 3 times 50 take 2 is 148. So, excuse me. C, I think, could have been 100 over 100k plus 48. Just squeeze it on there. All right. Last question. I did say I wanted to try and do this before James comes on, which should be in 3 minutes. So we're not making bad time. So the curve C has this equation, sketch C. Right. So this is a cubic. Goes through at -1, and it goes through at -3, which is a repeated root, and it's positive, which means it has that shape. So it means we're going to just skirt that, and then we're going to punch through there, and it goes through at 9, doesn't it? So 9. Show that the y by dx is equal to that. I wonder if we can avoid expanding this out by using the product rule. So if we write the first one down and then times it by the derivative of the second, so this is 2x plus 3 all to the power of 1 times by 1 plus, write the second one down, times by the derivative of the first, which is just 1. So now we expand this. So I've got x plus 1, 2x plus 6 plus x squared plus 6x. I don't think I've really saved myself a great deal of work here. 2x squared plus 2x plus 6x is plus 8x plus 6 plus all of that. So all in all, we've got 3x squared plus 14x plus 15 as required. So yeah, probably could have just expanded the whole thing and then differentiated, but I wanted to try it doing it a different way. I thought it might save a bit of work. So the point A with x coordinate -5, so we're out here. So A is somewhere down there. It lies on C. Find the equation of the tangent to C at A. Okay, so we need a couple of bits and pieces here. So calculator, where are you, calculator? Where art thou? If we put -5 into there, that will give the corresponding y coordinate. So that +1 times that +3 all squared. So -16, yeah, I can believe that. So A has coordinates -5, 16. And the gradient of the tangent there will be this. I'm kind of not doing my question thing very well. So 3 times that squared plus 14 of that is 20 when x is equal to -5. So we've got y minus 16 is equal to 20 x plus 5. What form does it want it? It wants it in the form y equals mx plus c. So y equals 20x plus 100 plus 16. Oof, plus 116. That's a pretty extreme. But I suppose this is fine because it is incredibly steep. So imagine the tangent here, yeah? We're going to go all the way up there. We need to cross the y-axis all the way up there at 616. Actually, I can believe that. Another point B also lies on C. The tangents to C at A and B are parallel. Right. So we've got obviously the tangent here, which has gradient 20. But there'll be another point on this graph, because this is going to arc upwards, where it is once again has gradient 20. So the question is, what other x coordinate has this 20? So if this is equal to 20, then 3x squared plus 14x minus 5 is equal to 0. Now we know that x equals -5, so the x plus 5 must be one of the factors, and then the other one must be that. Let's just double check. 15x, take yes. So it's when x is equal to 1/3 actually. So I've not drawn it very well, but actually it's there. So very shortly after it's gone through the axis, boom, gradient of 20. So when x equals, we're basically playing the same game as last time, 1/3, what is the y coordinate? If we do this plus 1, this plus 3 squared, oh yeah, someone has just pointed. Yeah, of course. Yeah, sorry, that's -16. Yeah, that's a good point. Which means 84. Yeah, sorry about that. I mean, still the justification of it being large was fairly okay, but yeah, I'm just like the y coordinate of this, y equals 400 over 27. It's just horrible. It's like there, but I suppose it's not going to be nice, is it, at a third? Again, I'm just falling into the trap of expecting everything to have a nice answer, which it needn't. So if we do y minus 400 over 27 is equal to 20 x minus 1/3, then that is the oh, sorry, what am I doing? Find the x coordinate of b was the question, so x is equal to 1/3 is the answer. So I thought it was to find the equation. So there we have it. That's the end of the paper. So x equals 1/3 at the other point at which the gradient is 20. And that's the end of the paper. So we're a little bit over time, but James is also running a little bit late, so that's absolutely fine as well. All right, and that was core 1. So this was the old school maths, A-level maths specification, which was basically what we call modular exams. Well, I'm saying we say that, it's probably a standard thing across all of education. So we would learn a bunch of exams, and then we had oops, sorry, my lamp is sneaking in there. So yeah, so we had we learn a bunch of stuff, and then we do exams in January. Then we learn a bunch of more stuff. We do exams in summer. But yeah, they've changed it now. So now you basically learn for 2 years, and then you do 3 big exams at the end. James, don't worry about it. Absolutely no rush, because we are now on exam number 16, and I think I've caught up with myself. No, I've done 15 in 16 hours. But I did that one very quickly, and I think I can do this one very quickly as well. So don't worry, James, because I am really keen to keep powering through quite quickly through these. Okay, so core 2. So this is another pure maths paper. And let's go. Let's just go straight into it. So, find the remainder of f of x when it's divided by x minus 1. So this is just f of 1, which is 2, take 7, take 5, plus 4. So that is 6, take 12, which is negative 6. Using the remainder theorem, use the factor theorem that show that x plus 1 is a factor. So if we do x of negative 1, we get negative 2 take 7 plus 5 plus 4, which is minus 9 plus 9, which equal to 0. Therefore, x plus 1 is a factor. And then factorize completely. So we already know we've got an x plus 1, which means out here we're going to have a 2x squared. We're going to have a plus 4. And then to get the intermediate terms, we got 2x squared. We need minus 7, so that must be a minus 9x. Let's just check it. Minus 9 plus 4 is minus 5, so that's absolutely fine. Oh, I'll just, okay, turn my music off and unmute the Discord there. Hello, James.
Hello, hello. Sorry, I'm late.
Yeah, absolutely no worries at all. I mean, I really respect you coming on here at like 4 a.m., so you shouldn't apologize for being late. It's absolutely fine. How you feeling? You still sound a little bit ill there.
No, I'm all right. I've got my cup of tea.
All right.
I will say, the bats are still flying outside my window here in the English home counties. There is some light entering the sky, and the birds are singing. So.
All right. Well, let's. You painted a very nice picture there, James. But right. So find the binomial. I might not be very talkative. I'll be honest, because I am keen to push through here. 15.
Yeah.
I've done 15 papers in 16 hours. So it's not terrible timing, but it's also not.
Yeah, we've got to get on with it. We've got to get on with it.
We've got to get on with it. So
Yeah.
So this is 3 to the 5th plus 3 to the 4 bx. Oh, I've forgotten my binomial coefficient. So 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10. So we should have a 5 in there. Oof. Plus 10, 3 cubed, bx squared, plus 10, 3 squared, bx cubed, 5, 3, bx to the 4th, plus bx to the power of 5. And I'm not going to simple. Oh, it does want everything in its simplest form. Are you this is a joke. What is 3 to the power 5? 343. 243. Sorry. So 243 plus 5 times 3 to the power 4. 405. Bx. Now that is 270 b squared x squared plus 90 b cubed x cubed plus 15 b to the fourth x to the fourth plus b to the fifth x to the fifth. Okay, now question B. Given that in this expansion the coefficient of x squared is equal to two of them, so 270b squared is equal to 810b. So therefore b is equal to 810 divided by 270, which is 3. That's nice. At least it came out with a nice answer in the end. Oh, find the first 3 terms. Oh, I really should read the question. It really pays here when you're trying to do it in a hurry. Okay, so x equals log base 5 of 10, which is 1.43, and then b. So if we do x minus 2 is equal to a third, then 3x is equal to 1 plus 6, so x is equal to 7 thirds. Should we check that? 7 over 3 minus 2 equals negative 1. 5 to the power of 1.43. Close enough to 10 with the rounding, that's fine. It's a very wholesome message that you just put out there, James. Nice.
Well, you know, it's just amazing, the global audience. I've really, really enjoyed it this year.
Yeah, I mean, it's nice when you actually have a YouTube channel.
Yeah.
Rather than just like friends and family. A couple of the Leyland AI coming in quite drunk. That was happened. Like I remember that was last time. No, it's all good.
Circle equation, nice one.
It's all good stuff. Yeah, and we're gonna get 16 over there, aren't we?
Mhm.
Which is 4 squared. So coordinates center -2, 1. Radius 4. The coordinates of the points to see what crosses the y-axis, giving your answers simplified thirds. Y-axis when x equals 0. So this term just becomes 2 squared. So in other words, y minus 1 all squared is equal to 12. So therefore y is equal 1 plus or minus the square root of 12. And is that a simplified third? Absolutely not. So 1 plus or minus 2 root 3. Fantastic. Oh, this looks good. Oh God, James, you missed them. You missed some proper questions. The international GCSE had an absolutely horrendous question. I was properly struggling with it. I really needed the help of there's a guy Y Wong. I think he cracked it for me. Well, there's a lot of good suggestions, and I think they would have worked, but he gave the suggestion that helped me to just get over the edge. And then on the degree level paper, the sets, numbers, and functions paper, that had a couple of the number theory. Oh, I mentioned that to you, that some of the number theory questions were not easy. Not easy. I was quite surprised at what was, especially on the IGCSE. I think that paper they accidentally made it too hard, or none of us could find the actual acceptable proper way that they intended for you to do it, because it was just like, yeah, it was a circle question, which usually is like my forte.
I was to say, that's your wheelhouse.
Yeah. So enough chit chat. The area of the sector OAB Well, this is just half r squared theta, which is 18 pi by 3, so 6 pi. B, the radius of the circle C. Right. Oh, okay, so if you draw the line straight down, nope. Like that. Have I missed some information here? That's really 6 pi by 3. Touches there, touches there. So that is a right angle. Oh no, this is fine. So I've got a 3. I've got a pi by 6 radians in there.
Yeah,
Yeah, this is it. And then
this is the way.
this is our x. Yeah, it took a second. Again, usually instantaneous, but it's as if it's 4 in the morning and I've been doing this for 16 hours. So we've got the old tan pi by 6 is so 3 of those will give me x. 3 tan pi by 6 is something not radian looking, so let's do that again. Root 3. Yeah, I suspected it might be root 3, but I didn't want to commit. And then C, find the area of the shaded region. I think we all knew that question was coming. So the area of the circle is pi times root 3 squared. So 3 pi. Therefore, 3 pi is the answer, because it's 6 pi subtract 3 pi. That's interesting, isn't it? So a pi by 3, so if you will, a 60-degree, a sixth of a circle, you draw the circle defined by the maximal circle in there, and that's half of the area. I love little pleasing things like that. Good
Yeah,
stuff.
this is a nice one. I like this.
So, second and third terms of a geometric series are that and that. So this is geometric. Find the common ratio. Well, 192 times r is equal to 144. So r is that 144 divided by 192, 3/4. The first term, well, the first term a times 3/4 is going to yield 192. So if we do 192 divided by 3/4 is one way of doing it. I guess it's 256. The sum to infinity, so this is 256 over a quarter, which is 1024. And then the smallest value of n, for which the sum of the first n terms of the series exceeds 1000. Okay, all of a sudden we've got a question on our hands. So, oh god, what was it? I forgot this earlier, but I'm feeling like that is the formula for the sum of a geometric series. What are we thinking? Does that look good to you?
You're asking the wrong guy.
Yeah, sorry. Yeah, I'm asking the. I've got the formula book here. A times. Yeah, this is right. Yeah. Yeah, we discovered this about 14 hours ago.
Yeah, I will say as well, the stream is a little behind, which is what you would expect. But,
yeah, it is. And also, I think after this paper, we'll switch over to part 3 as well, because that should have been at 4. We should have done that when you joined, actually, but it doesn't really matter. So, what was the first term again? 256?
Yeah.
Times 1 subtract 3/4 to the n over a quarter. So again, we've got this. We want this. I don't want to use trial by improvement. We want this to be greater than 1000. So 1 minus 3/4 to the power of n to be greater than 1000 divided by 1024 is that 1 minus 125 over 128 has to be greater than 3/4 to the n. Do 1 minus that. Wondering what happens there, because this is looking like that. Okay. Just writing it again over here, because I want to not cock up my logarithm. So log base 0.75 of 3,128. Now, I think when you take logs, you do flip the sign, don't you? Let's just see what we get. So 0.75 at 3 over 128. Might be wrong about that. So I think, well, maybe not. N is greater than 13.04. So I'm thinking N is 14 is the answer. Let's just check it, because it's not hard to check. If we do 256 times 1 minus 0.75 to the power of 13, and then divide that whole thing by 1 minus 0.75, I think this should be less than 1000. And it is. Just. And now, 14. Yes, so n equals 14 is the answer. So maybe you don't reverse the... This is wrong here. Yeah, sorry about the latency. I think when I set up the stream, I might have, like... I don't know. It has been fluctuating, though. I mean, I don't know how it fluctuates, because they're kind of both running at the same time, but it's just... it's bizarre how it works.
The thing you're thinking about log flips is you have to be careful when you're dividing by a logarithm in an inequality, because the logarithm could be negative.
Yeah, there's things worth paying attention to there.
Yeah, but it is monotonically increasing, right? So it should be okay.
Yeah. No, you are. Yeah, you're right as always.
No, I'm definitely not always right.
No, maybe not in this arena.
I was going to say, you must be tired.
Yeah, I'd never admit to that, really, would I? I've just seen Sandra's message. Oh, good night, Sandra. Thanks for joining. Yeah, thanks very much. Really appreciate it. You leave me with the old man. So, we've got the x plus 45 is 41.81, and then the old sine graph. That's how I do it. So 2/3 is about there. We've got that one. So if we do 180, subtract that, then we get 138.19. However, I'm also going to take this one. So let's do 41.81 plus 360, which I definitely don't need. What am I doing? Because, oh no, I do need this. I do need this. Because, so we also get 401.81. So therefore x, that solution actually doesn't matter, because we want solutions between 0 and 360. So that, when we subtract 45, is going to vanish. 138.19, take 45, is 93.2. And then 401.81 subtract 45 is, we're just in, so 356.8. So it's actually that one and that one that counted in the end. Okay, now B. Find for... Oh, right, we're really mixing up the question here, aren't we? Half degrees, half radians. What next? So 2 sine squared x plus 2 equals that. Okay, so we'll swap that out for a 1 minus cos squared x plus 2 is equal to 7 cos x. That's 2 minus 2 cos squared x plus 2 is equal to 7 cos x. So, not 2x, 2 cos squared x plus 7 cos x. Subtract 4. If we shove it all onto the right-hand side, is that. And now, come on, give me a factorizer. It's been awful today, the number of quadratics that have boiled down to something that doesn't factorize. Absolute nuisance. Plus 4 over here, minus 1 here. So 4 times 2 is 8, take 1 is 7. So cos x is half. Cos x is equal to negative 4. I think we're good to reject that because cos x is strictly between minus 1 and 1, or equal to. And therefore x is equal to, so arc cos of half, which is going to be it's pi by 3. Okay, and then the old cos graph. So at half, if we do pi by 2, subtract that, we get, so it's pi by 6 in that little gap there. So we need to add this on to 3 halves of pi to generate, no, 3 halves of pi to generate the other solution, which is 5/3 of pi. So those are my solutions. I love this. You must show clearly how you obtained your answers. As opposed to what? Like, it says that on all the questions, surely.
Yeah, that's interesting, isn't it?
Well, interesting is a strong word, but
I was being generous.
You'd be, yeah, a little bit too generous there. Wow, that is a cuboid. I don't think I've ever seen a cuboid like this. This is mental. What is going on here? Oh, you're gonna have a shock when you see this, James.
I was going to say, I'm really excited now.
I don't know what it is about it. It's just like, it's very striking. You'll know what I mean when you see it. But yeah, it has a rectangular cross section. Do you not think?
That is a cuboid.
What's wrong with the old oblique drawing, or the isometric? This is just this cuboid's gonna leap out the page and punch me in the face.
It really is. Thank you, CC, for the $5.
Oh, awesome! Thanks very much for joining there. That's awesome.
I really think this cuboid is absolutely worth $5. So
yeah, I think so. I genuinely, I don't think I've ever seen a cuboid written this way. This is just absolutely bizarre.
So, someone at EdXL got some new software that year.
It's absolutely true. And not David in the comments there. That's brilliant because I don't know if you've watched any of his videos, but he makes some gorgeous animations in Blender and things like that. So he's looking at this being quite upset at what we're seeing here, which I'm very yeah. This is some some basic ass CAD software that they found. And right, let's whip up a cuboid with this. Anyway, I know the cuboid is the real star of the show here, but let's try and proceed with the question. Let's just try let's try and just keep a level head here because we can't get too excited about this. So a cuboid has a rectangular cross section with a length of the rectangle is equal to yeah, we got it. And then the volume is equal to 81 cubic centimeters. So that the total length of the 12 edges of the cuboid is given by that. So let's call that y, and then we know that 2x squared y is somehow equal to 81. So y is equal to 81 over 2x squared. Now the total length of the 12 edges of the cuboid. Right, so we've well, each edge appears 4 times, doesn't it? So we've got 4 2x's, we've got 4 x's, and we've got 4 81 over 2x squareds. So that is 8x. No, sorry. Yeah, 8x plus 4x is 12x. Plus, what's 4 times 8? Well, no, it's just 2 times 8 to 1, which is 162 over x squared. Is that the thing that we wanted? Yes. That's good. Use calculus to find the minimum value of L. So, obviously, L changes regardless of how we build the cuboid. We want the minimum. So, I think if we find dl by dx, this is going to be 12 subtract 364 x to the minus 3, and if that is equal to 0, then 12x cubed is equal to 364. Now x cubed is, have I got that right? 360, because I wanted that to be a factor of, I wanted 364 divided by 12 to be something nice, but it isn't. X equals the cube root of that. So unless I've screwed it up, x is 3.12 is that, which means when we push that into L, we get 12 of it plus 162 over that squared. So the minimum value of L is 54.1. Justify by further differentiation that the value of L you have found is a minimum. Well, d2L by dx squared is going to be, so 364 multiplied by 3 is 1.
Oh, ignore me. Sorry, I'm being dumb. Sorry. Apologies.
That's okay. It's that. And then when we put in 3.12, clearly this is going to be positive. So therefore it's a minimum. Yeah, I think someone's commenting that I miscalculated the derivative here. I can very much believe that because we got such a disgusting answer. I don't know where I've gone wrong. 12 differentiates there, and then 162 times 2. Oh, 324. Oh my god. Yeah. I didn't have a good feeling about it. You know, all the way through. I knew it was going to be something better than that. 27. Which means x is equal to 3, which means L min is equal to. I knew that. I should have been a little bit more careful there. But all the way through tonight, I've been like, whenever the question has been messy, it's just turned out that way. Whereas in this case, obviously we put 3 into there, so we get 1092. Divided by 81, and we get a positive. It doesn't matter what it is. It's going to be positive. Positive x in there is going to be positive. So it is indeed a minimum. Yeah. So thanks for the heads up on that, David G. He's been one of the people who's been on the ball tonight. Quite a few people actually. I think they could have their own go at one of these challenges.
Yeah, there's been some great comments.
Yeah. Some smart people. So the straight line with that equation cuts the curve here. Now this has got integration written all over it. Use algebra to find the coordinates of the point A and the point B. Well, A is just minus 4, 0. And B, well, B we actually need to do some work. So x plus 4 is equal to minus x squared plus 2x plus 24. So therefore x squared subtract x subtract 20 is equal to 0. Now we already know that x plus 4 has to be a factor, and the other one must be x minus 5. And is that right? 4 take 5, yep, yep, all good. So x equals 5. And now that means y is equal to 9. Should we just have a quick check on that? Minus 25 plus 10 plus 24. Is 9. Yeah, that's fine.
Yeah.
So B is 5, 9. Okay, now it's integration time, no doubt. The finite region R, I love that it says finite region, you know, just in case we're in any doubt, is bounded by the straight line and the curve, and is shown by Fig 3. Okay, so if we do the integral of minus x squared plus 2x plus 24 between -4 and 5 with respect to x, and then we subtract that triangle there, which has a base of 9 and a height of 9. What? Doesn't look like it, does it? But I think it does. I think it's
No,
just,
no, it absolutely does.
yeah, it's just really not drawn to scale.
It absolutely is not drawn to scale. Yeah.
Well, yeah, I mean the scales of the axes could be different, but so that's 40.5. And again, I swore to myself the next time that this question came up, because somebody earlier suggested, why don't you just like do the integral of that, you know, but actually the integral of that subtract the integral of that is just the integral of that subtract that. And I don't think I've ever done that in my whole life, because for some reason in my head I'm locked into the view that integration happens with curves, but there's no reason why you can't integrate a straight line. So yeah, it's just something that I don't really consider.
Yeah, I wouldn't either. I mean, it's a triangle.
Yeah, well, to be fair, the earlier one was a trapezium, which was a little bit nasty to actually work out, and that it was a much cleaner way of doing it. But it was but yeah, this is just a triangle here. So this is going to give the solution. I think I'm just going to stick all of this in the calculator. Let's not even mess about. So I've got minus 5 cubed over 3 plus 5 squared plus 24 of 5, which gives me 310 over 3. And then I need to subtract. So if I do -4 equals, then I want to do minus that cubed over 3 plus that squared plus 24 of that. Come on, wrong button. Is that. So we're going to be plussing 176 over 3, and then we subtract 40.5. So 310 over 3 plus 176 over 3 subtract 40.5 is that. 243 over 2, which is 121.5. Hopefully that's the answer.
Yep. 121.5, yeah.
121.5, yeah.
Yeah, all good.
All right, and that was the end of core 2. So not a bad paper. Quite straightforward, really. Just gonna get straight into core 3 here. Let's not even. Let's
keep moving.
Let's not dilly dally.
14.5 hours in, 16 papers complete. So.
Is that right?
Yeah, let's keep going. Yep.
So this is exam number 17, core 3. So I think it's fair to say no, it was 16 hours in. 16 hours. 16 hours.
16.5 hours in, yeah.
Yeah, 16 and a half with 16 papers done. So we've almost caught up.
Yeah, let's keep moving.
I think with
be
core,
a lady tonight.
yeah.
But actually, it's like a YouTube limitations thing, I think.
Oh yes, and we did say we're going to go to part 3, didn't we?
Oh yeah, let's go to part 3.
So yes, yeah, it's a good point. So YouTube, I think if it runs over 12 hours, it doesn't save, and I do want to save it for prosperity. So we are going to have 3 separate streams on here. You'll notice that a lot of streamers do that. It's like if it's 24 hours, it'll be 3 blocks of 8, even though we're stretching the definition of 8 because we've been pretty wacky with how we've done it. So if you could kindly, if you would like to carry on watching, please migrate over to part 3. I will stick, the link is in the description. I'll also stick a link into the chat. So there's the link to get onto part 3. And I will see you there in just a few moments.